Hi, my name is Royal O'Brien, and welcome to Live Coding, an Alexa-enabled Twitch extension. With me today, I have everybody involved from the Twitch and Alexa teams, as well as AWS and Game Tech. And for introductions, I have Mimo Doring. He is a senior solutions architect over on Alexa. I have Gabe Holland, who's a technical evangelist over on AWS services. Myself, I'm Royal O'Brien. I'm chief technical evangelist for Amazon Game Tech. And to my left here, I have Travis Brown, who's a lead integration success engineer over at Twitch. And then I have Braxton Lanchel, who's also an integration success engineer with Twitch. So we'll kind of get started. So first of all, guys, if you want to have a seat over at the couch.
Absolutely.
So some of you are curious about some of the parts of what Amazon is doing. One of the big things is that we have a piece called Game Tech. And Game Tech really is what we're doing about gaming. So the quick answer is, how are we addressing this? And the things is that we're looking at all of our services and doing quite a bit about it. Not just where you have to pick and choose what you want, but also being able to put a lot of these solutions together for you. So it's kind of everything from global infrastructure, like AWS and hosted instances, over to the Alexa skills, things like pre-built game services like GameLift and GameSparks, also to the content creation tools like Lumberyard, and Twitch, and then of course all the marketing pieces with Amazon Marketing, and of course reaching all of the millions and millions of people with Twitch. So with that in mind, as we're on this feed, we're going to be monitoring a channel of what's going on in the Twitch feed. So if you have questions, absolutely put them in there, and a lot of times we'll stop everybody and answer your question and address some of the stuff in line. So don't be shy. We look to seeing everything from you. So let's kind of get...
We also have some mods on the channel, right? So if you're on chat and we can't get to your question, feel free to keep asking, ask your questions there. We have people, experts on there, answering questions, typing them up.
Yeah, the moderators have a direct line to get questions in front of us on screen too. So don't be shy about asking.
Yep. So going from there, let's kind of start off with Alexa. Memo, tell me a little bit about it. Where did it all start?
Yeah, so the idea behind Alexa, or the dream behind Alexa, was the Star Trek, right? We're all nerds here, and we would all love to be able to just say, computer, make this happen or that happen. So that's kind of what was the whole idea behind Alexa, and it's really grown, and it's become its own thing. I've been with the Alexa team for close to 3 years now, and it's day and night from when we started and where we started, and we were a handful of people, and now we are pretty much a building full of people, so it's really, really cool to see how much it's grown.
No chance we could get Majel Barrett to do a cameo Alexa voice for us?
We can only dream. We can only dream.
Okay. So how big has it become?
It's huge, right? So there's millions of devices out there that are Alexa enabled. Some of them are Echoes or Echo Shows or Spots, which are Amazon devices. But there's also all these other devices out there from different manufacturers like Sonos or Eufy or TVs from Hisense. And pretty soon, some cars are going to start coming off the line with Alexa built into that. And each of those devices is special in its own way. You've probably been driving down the highway with your window open, and you can tell how noisy a car is. So all our engineers and the car manufacturer engineers had to get together and figure out where the microphones go, where the different speakers go to actually capture the speech really well. Nice. And that's also translated to developers. So we got over 30,000 skills. We call them skills. They're basically voice apps. It's how a developer teaches Alexa how to do something new. Get a movie ticket, get the scores for a game. I'm Mexican, for example, so getting the World Cup scores is very important to me. It's like religion in where I'm from. So all those little things that you can teach Alexa, and we've seen great adoption from developers and super excited, and we're making more tools available to them all the time.
So what are some of the really cool things that you've seen and some of the different places they've really used it, though, that like in the industry you wouldn't expect?
Yeah, so I don't know if I wouldn't expect it at this point, because people took to duck to water with it, but like smart home for voice, it just makes so much sense, right? I guess a lot of us have experimented with smart home, but it's always its own app for this little thing, and then you forget what the app is, and you need your own login, and it's pretty janky when it comes to UI. But when you can have a single voice UI to control the whole house, and you can just yell out commands. I know Jeff on my team, hello Jeff, is really a big fan of being able to just trigger his AC, because his furnace is in the basement, and he sits in his home office in the 3rd floor. So he could just yell, and then suddenly the AC is coming on, and he didn't have to get up, he didn't have to do anything. So removes friction. Another one that I really love is hospitality. So being able to just walk into a hotel room and be able to say a command, get the menu for something, or get the amenities on location. It's really, really cool.
Very nice. So really, I mean, anything that you want to do, you can use Alexa and be able to put it together and drive almost anything you can think of. So it's virtually unlimited as to what you could really do. And that's half of what we're talking about today. And the other half of it is going to be actually talking about Twitch, which many people know. And we're going to go over here to the couch and talk to the Twitch guys. And so, you know, again, the same question for you guys. I mean, Twitch, for those who don't know, what is it?
Well, everybody that is watching this is on Twitch, but man, Twitch has gone from something small and silly to just millions and millions and millions of people. For everybody that knows the history of Twitch, you know, it started out as Justin TV, which was, you know, a few guys that just pretty much stream themselves in real life. Turns out people like to watch video games, who knew? And that's really what gave Twitch the explosion of how it became so popular. You know, nowadays, it's not just about video games, it's about, you know, the creatives, the arts, you see cooking, live events. I mean, you can find any category and do anything on Twitch. Nice. But it's just exploded and become incredible.
So, I mean, how big has it become?
We have hundreds of millions of, we have millions of active users. We have so many people watching at any given time. We also, one of the things I think that's key to Twitch is it's a social experience. So it's about having a shared experience when you're watching, you're in chat, and we'll talk about today the next evolution of that is extensions and kind of bringing that interactivity one step closer.
So what does it really do for the people who actually use Twitch and some of the products? I mean, why do they really do that? What's in it for them?
There's a lot in it, and it all depends on who you are in the process as well. I mean, if you broadcast, you can get monetary value, obviously, but the biggest thing in my mind is just community. I mean, it drives so much community. Whether you're a gamer or you have a really niche hobby or interest, like in the arts, you can find it on Twitch, and you can find other people that also like that stuff on Twitch. So, you get there, you connect with people, and you just find that sense of community, and you're able to do things together, play together, talk about things together. I've made friends on Twitch, and anybody who's really spent a lot of time on Twitch, I'm sure, has also made friends on Twitch, and it's really, I mean, it's amazing.
What's it do for developers?
So with the extensions, I mean, anybody can make an extension. So there is now a sandbox and a platform for anyone to come up with their own creative, interactive experience on Twitch.
So if I'm a game dev and I'm building a game, why do I want to do things with Twitch? What's it going to do for me?
Yeah, as a game dev, it's a really good way to keep people interested in interacting with your game when they're not playing it. So as much as we'd all love to, we're not going to play video games 24 hours a day, but that doesn't mean we can't be involved or interacting with the game when we're not playing it. So whether you're watching a stream or like when you're watching a stream, integrations like extensions can bring the interactivity and keep you always involved with the game. Some really good examples of that, which we'll probably talk about shortly, but things like League of Legends Stats Tracker, the Destiny Armory, things that, if I'm watching a Destiny 2 stream, I'm able to see what the streamer's loadout is, and that, then it's like, oh man, I need that loot now, so I'm gonna go back and play eventually. So it's kind of like this endless loop, and we're watching and playing games all the time.
So it's kind of cool. People get to see everything that's in the game, and it becomes its own marketing vehicle that, in ways that you never even knew your game could be played or done. That's just a whole new thing.
Yeah, I mean, there's new levels of engagement too. So we're seeing more and more games that are kind of experimenting on using extensions to influence or change the game state of a broadcaster. So like we had the Project Darwin extension, which is like a battle royale game. Viewers could vote on which zone would collapse, so they're actually changing the game state, and they're having an impact on what they're watching.
That's very cool.
I like to say that Twitch is your game's biggest commercial, and it's always running. So.
Nice. Well, so for today, one of the things that we want to do is we're going to talk about some of the pieces of how we put these together. So we're going to go back over on the dev desk here, and we're going to talk a minute about what are we going to do today. So Gabe, you want to tell us a little bit about what are you doing today, kind of at a high level?
Sure. So what we're going to do today is cover how to build a Alexa-enabled Twitch extension. In this case, we decided what we would build is a raffle. And so we're going to cover the parts about how do you build a Twitch extension, what are the component parts to that, the development flow that I used for getting a raffle extension built, and then how to have an Alexa skill interact with that extension as well.
Cool.
Yeah, so Gabe built this extension, and what it's doing, it's actually a raffle, right? And when you're playing, if you're playing a video game on Twitch and you're in the middle of Battle Royale, the last thing you want to do is let go of the controller and type something in to interact with your users, or your viewers rather. So we want to be able to give streamers a way to interact with them and have a really engaging stream, and voice is the perfect medium for that.
Very nice. So the idea here is that when we first started out, we were looking at the high-level elements of, what can we really do? How can we make this where it's something that actually is useful and would make sense? And so the idea we started out with that we've seen in certain games where you have like gold farmers or people are doing different things, and that we found that there's kind of a new way that people are approaching it. And what they do is they build teams, and these teams turn around and they look at, how's the game going and how do I get people who want to play this high-level content, but they can't really get to it. And so what happens is they go and they say, hey, come look at my Twitch feed. And then they bring people from the game to the Twitch feed by posting it in the open broadcast channel. And when they get there, they go, okay, if you're one of the guys that we pick from the Twitch feed, you can join us in this game and get the high-level content and be able to play along with us. And so what happens is people join the Twitch feed, and when they're in there, they kind of do this raffle where they have them join and be able to get in. The problem is that when they go to do that, the person who's running the stream has to get out of the game, do the commands, invoke all the pieces, and kind of keep going through all of that. And the reality is that one of the hardest things with a lot of Twitch users that are running live games is every time you have to get out of the game or stop doing it, that means you're distracting the feed. Yeah. And they want to find better ways to engage with the feed. So that was the idea behind this. So that's what we're going to do today. We're going to allow a Twitch streamer to be able to start up a raffle, to actually communicate and work the community without actually ever leaving the game at all. And we're going to use the best medium, Alexa, to make it happen. So, tell me a little bit about the high-level pieces of this. Give me an idea of the architecture, what we're doing here at a high level.
Sure. So at a high level, let's break it down into talking about what makes a Twitch extension, and then how is Alexa going to talk to that extension. So Twitch extensions have a front end, and that's basically just a web app. At the end of the day, you're serving up JavaScript and HTML to present an interface to the viewers on the channel. There's different types of Twitch extensions. There's a panel extension, which is what I built my raffle extension as, which just shows up underneath the video content of the stream. And you can also do overlay extensions, which will show up as an overlay, not surprising. And then the back end for your extension can be anything, right? It's a service somewhere. If your extension, you might not even need a back end depending on what your extension is doing. But if you have to maintain any state, if you want to have any kind of API, you're going to need to host that somewhere. So I built a back end for my extension, which, by the way, just a jargon alert, the Twitch developer documentation talks about EBS, and what they mean by that is an extension backend service. So let's not confuse that with the AWS concept of EBS, or the Elastic Block Store.
Which is something that tripped up the group here, right? Like we're talking about EBS, but we weren't talking about the same thing at all.
Yeah. So for this stream, if you hear me talking about EBS, I'm referring to the backend service or the API that my extension is going to talk to. So that needs to get hosted somewhere. In this case, I should also mention the front end is hosted by Twitch. They take the content for your extension and they host it off of their servers. You can test it locally, but then when it comes time to publish that extension, Twitch ends up hosting it. So the backend, though, that's up to you, or whoever creates the extension. You get to host that wherever and however you want. So for the purposes of this stream, I decided to host it on AWS with a simple setup that we can get into a little bit more detail later. But basically, it's just a Lambda function that is fronted by API Gateway that hits the Lambda function to respond to different HTTP requests from the extension. And I use DynamoDB to store some of my state. And we'll unpack a lot of that and what those services are and how they work a little bit later.
And so everything we're going to see today, by the way, you'll actually have access to it. We'll be putting it up on GitHub. So you'll find it on github.com/alexa-labs/ Alexa-twitch-raffle. You'll be able to go there and get the source code on everything we're talking about here and play with it yourself. I want to go back to what he was saying, though, with Lambda. Explain, what exactly is Lambda, and is that, tell us about between hosting and serverless computing, and let's start there. It seems like a good place.
It's a great place to start. So, serverless computing, it's I won't say it's a buzzword anymore because I think we've just been talking about it for a long time. I think it's just the word now. But basically, Lambda is AWS's service that lets you run a function in the cloud. Now, the nice thing about this is, traditionally, if I were to make a backend API of any sort for a Twitch extension or for anything else, some API service, Back in the old days, I'd have to provision a server myself somewhere, whether that's a virtual server or even my own server in a rack somewhere. The idea being, I've got a server that's running all the time, and I'm paying for that time that it's running.
But furthermore, really, you got to pick what kind of metal it's running on,
Yep.
the OS, and then harden it, manage security, do
Exactly.
all these different things, right?
And then scalability as well.
Yeah, exactly.
Right. So there's a lot of things that we used to have to worry about. The nice thing about serverless computing in general is you tend to not have to worry about that stuff with serverless options. And so also serverless means a lot of different things to different people. To me, I use serverless to just mean using services that are going to scale for you, where you don't have to worry about scalability and managing those services yourself. Oftentimes, or the security for them, or at least there's a shared security model, and you don't have to worry about like the OS hardening and things like that. So Lambda is a nice way to build APIs, except you need something in front of it to take the request, and that's what API Gateway gives you. So API Gateway is a service from AWS that lets Amazon run a web server, basically, and when requests come into the URL endpoints that you specify, you can tell API Gateway, please send these requests to this Lambda function, for example, and then I'm only paying for the execution time of the Lambda in 100 millisecond increments. So it's scalable because I don't have to worry about scaling that Lambda. AWS handles that for me automatically. And it's cost efficient because I don't have to over provision services or servers in order to meet unexpected demand.
So I guess one of the questions is though, we're talking about Lambda, like what languages can you actually use to write this in?
Yeah, so, and fortunately enough, like I'm also using Lambda for the Alexa skill that I built to hook up into the extension. So we're kind of staying in the same ballpark, and the languages that are available are Node.js in a couple of versions, 8 and 6, and 4 is kind of going out. It's no longer going to be available. We also have Python 2.7, Python 3.6, Go, I can't remember what version of Go, and then C#.
Yeah, and Java.
Oh yeah, Java
Yep.
8 and 9, right?
I don't remember which versions.
Yeah.
That sounds right. I haven't written any Java code in a long time, and I'm happy about that.
So, we've talked a little bit about what the pieces are. So let's kind of dig in a little bit more. And I'm going to go back over to the couch here. And what we're going to do is we're going to talk about some of the different concepts and elements here. And this is for you two gents. So my question here is really, what are some of the popular extensions and concepts that you've actually seen used in Twitch?
Yeah, I mentioned a couple of them earlier, but it's really amazing that extensions can be used for anything. I mean, things that are useful to the game that people are watching, or things that are just like ridiculous and silly. Good examples of that, like I mentioned, are the Destiny 2 tracker and the League of Legends stats tracker. If you want to watch stats on the game the streamer's playing, if you want to see like the armor and the loot that your streamer has in their game, that's super useful and helps you engage and understand the game. But then there are also like super silly things like a Kappa pet. And the world didn't know we needed a Kappa pet until we had Kappa pets. So get yourself a Kappa pet, and it lives in the panel, and you can feed it, you can pet it. A little creepy, but super awesome, and the community loves it. So keep it alive.
It's kind of a cardinal sin if you let your Kappa pet die.
Right, yeah.
This is a bad thing.
If the Kappa pet starts dying, then the community is going to jump on it. You got to keep that thing alive.
I'm interested in the Pixel Finder.
Or like last year, it had somebody create an extension where you could control his Christmas lights at home. So it's pretty awesome.
So,
that sounds like the ultimate troll, though.
yeah, that is. Well, I mean, so give us an idea. What are the moving parts? If I'm going to build an extension, what are the moving parts to actually build one?
Yeah, absolutely. So there are fundamentally, two major components. You're going to build an extension that is going to be the front end assets. So this is the HTML, JavaScript that are actually going to be loaded in the browser when a viewer hits a channel. So that's what's going to be running on their side. That's going to be calling back to your backend, which, as Gabe mentioned before, can be really hosted anywhere with any service. But for this example, we're going to be running it on Lambda through API Gateway.
So it's interesting. I actually had a question that came in from the Jackman who just said, does this raffle API take into account all the legalities of raffles in different locales? I know some territories have very strict raffle giveaway regulation. It's kind of outside of it, but if you really wanted to get into that, because we actually have the source code, you could make it compliant with whatever you want. It's not like some kind of pre-built binary and good luck, I hope you make it. So, you build in what you want to make sure it's compliant, the reality of it. And that's actually the sweet part of this is we're going to show you how to do it.
Yeah, so there's a lot of the plumbing for you, but we'll take the leap of faith.
You can take the rest from there. So
yeah, we didn't have a lawyer on stream this time.
No. That one was
time.
pretty easy though.
Yeah.
But hey, man, that's we said we'd address them. So, let's talk about tying the different parts of this. Like, how does it tie into the context of what we're doing here? Like, what is that? How does the plumbing and things like that? How's that tie into what we're doing here?
Yeah, totally. So Gabe talked about it a little bit. You build the front end, which is the extension, the panel extension itself, which is just HTML, JavaScript. I think we used React for this one. And then the back end, which is the extension backend service, and then the actual API gateway and Lambda functions. So you have that front end, which talks to the back end, which hits Lambda. And then, the Alexa skill is also talking to Lambda and hitting the back end. So it's kind of like a three-way piece here with Twitch, AWS, and Alexa, which is probably pretty obvious by now. So the pieces hook up.
Well, if I'm going to build this, do I just jump into Docs? Is there something I can use to make life easier? Like, what do I do to get into this?
Yeah, so we're going to talk about it a little bit later, but there is a Twitch developer rig to kind of just get started. It's got a Hello World sample that you can install.
I've actually got it up on the primary if we want to go full screen and you can maybe voice over while
Okay, yeah. Go
All right,
for it.
so let's go ahead and get the primary machine full screen, and let's go ahead and jump into the developer rig.
Yeah, so you'll find this on GitHub, Twitch dev/developer rig. And in the README, you've got all your getting started information. There's an introduction as to how you can use the rig, but essentially this helps you get started all locally. So you don't have to push any binaries out to Lambda yet. You don't have to host anything yet. It's all going to be running on your local machine. And first, you're just going to need to actually install some prerequisites. We'll take a look at this. So you're going to have to install Node and Yarn. You'll run the Yarn install script. And then you'll need to actually go out to the developer site and create an extension. There is an extension, like a developer onboarding process you need to go through. But once you've been approved to create an extension, here's where you can actually manage the lifecycle of your extension.
Well, let's go ahead and switch the laptop just more on screen, so you can also kind of see us at the same time, so we're not just talking through a browser.
So all you really need at this step is you're going to come away with a few data points to put into the rig. You have the client ID of the extension, you'll have the version of the extension, and the generated extension secret. We'll talk a little bit more about that when we talk about what JWTs are and why JWTs are necessary.
Yep.
And then you'll also add a host entry. So localhost.rig.twitch.tv will then just be a loop back.
Okay.
In the instructions here, I have to say, I followed them all on my own, and I was able to get started without needing to ask for any help from Travis during that part of it. So as I was building this, we wanted me to act just as a proxy for all of you developers watching on stream right now, and see how could I build this, how easy was it for me to interact with the docs, and I had people like Braxton and Travis to get me unstuck with the Twitch side of things, and Memo to get me unstuck with the Alexa side of things. But as far as getting the local extension development test set up, the instructions here were pretty comprehensive, and there was only one gotcha, which I figured out, and I'll explain it when I run it.
Okay, yeah. Definitely let us know, because we're also, this is a open source project. Yeah. So we take external contributions to make the rig better. So if you guys ever see something that you got hooked, a gotcha, or you see a bug, we're looking through and we're processing pull requests all the time.
Yeah, and same for all the Alexa stuff. If people on chat or whatever, they can hit us up on Twitter, or they can go straight to our GitHub repos and submit pull requests. We love to see that from the community.
Well, let's go ahead and, if anything, let's get the dev rig kind of up and going at least showing how you put a sample together.
Yeah, and you've already got it running, right?
I have it running on my machine. I don't have the sample running, but this is probably a good time as I need to show what does the extension that I built look like, and we can just show the,
Sure.
what I managed to build, and then we'll walk you through all the component parts of that in detail. So this looking here on my computer now, this is the localhost rig set up, and there's two components to this. Well, I have two up. The rig makes it easy to test how your extension is going to look for different audiences. And so I added one view as a broadcaster and one view as a logged in viewer with a linked account. And then what we can see here is that there's special broadcaster controls that are only available for the broadcaster. By the way, I should apologize in advance. Basically no effort went into making this extension look pretty. I felt like the interesting thing about this stream was going to be showing how do you build a Twitch extension, how do you do something neat with it, and how to get Alexa talking to it. Not let's do an hour about how to style HTML with CSS and prettiness there. So that's TBD. If any of you want that as an exercise going forward, you can take this code and make it pretty. But I'm going to apologize in advance. It's minimal styling. So the broadcaster can start a raffle, and we can see here that the default state says no active raffle yet. And if the broadcaster starts a raffle, then a message gets published to all the extensions of the viewers, and they can see now that a raffle has started, and they can join. And if they join, then it tells them that they've joined, and then the broadcaster can pick winners from the raffle for whoever's joined. And in this case, you see some confetti if your name gets picked. The reason it played on the broadcaster one too, it has to do with one intricacy about user IDs from the Twitch rig that we'll get into a little bit later, from the developer rig rather. But in general, that's the sort of the flow. You start a raffle, each viewer can enter, pick a winner, we'll pick a random person who has entered, and then when the broadcaster's done, they can click finish raffle, and that kind of resets the state.
And so now you said you actually started using a certain framework to actually build this out with.
Yep.
And so tell me a little more about how you got that starting to go and kind of some of the gotchas that you ran into with it.
Good call. Sure. So I have a long history of building web apps, and my current favorite library to use for front-end work is React. So I just started with a plain vanilla Facebook create React app. So if you haven't ever used React before and you're interested in getting started, I recommend this as a place to start. You can just look for the create React app module on NPM, or head to the Facebook repo for create React app. There's a lot of great instructions here on how to get started with it. And so I started with that, and that was just a vanilla React app. But one of the things is you'll notice in the developer rig, that everything has to be served over HTTPS. And I mean, that's a good practice in general, but it does make your local development a little more difficult in that when you start up, so one of the things Create React App gives you out of the box is a local development server that you can hit up, and anytime you change your code, it gets automatically refreshed in the browser. And that's great, except it starts on HTTP. And so if I wanted to use that live auto-reloading development server and have that content show up inside the developer rig, I needed to serve over HTTPS. And so that was just as simple as what Create React App has a command you can do called eject, which basically just takes and exposes to you a lot of the underlying decisions that the Create React App project makes for you in order to make developing with React a lot easier. And it puts it front and center so you can make any modifications you need to make. For example, adding a small stanza to say, to the web server config saying, I'd like you to run over HTTPS, and here's where you can find the SSL certificates.
Sweet.
So that was one gotcha I had to figure out was, I need to serve this over HTTPS. How am I going to do that with Create React App? And then I just figured out that you need to eject and make those changes.
And so for those who are just now joining us, we're actually doing live coding of an Alexa-enabled Twitch extension to be able to show everybody how you build both sides of the house and tie them together. We've got the teams from AWS, from Twitch, and from Alexa here showing how to build all of these things. I did have a question that came in, and the question comes in for the Twitch folks. It's from Alistair Plays. It says, is there a way for the extensions to interact with the chat area?
Yeah, so actually you could tie together the state of your extension from the backend through IRC to chat. So I think the best way to actually create a programmatic bridge would be having a backend connected to IRC, and then basically you have an extension plus a bot that's hosted in one place. So that would actually be pretty cool. But one of the things that we wanted to do with extensions is kind of have an area for interactivity, because before extensions, even before Twitch had a developer organization, we're all familiar with Twitch Plays Pokemon. And that was kind of a revelatory moment for us all that, here's a new interactive experience where people can engage in interesting ways. And in that case, you're actually putting commands in the chat. So Twitch Plays Pokemon was awesome, but there was very little chat actually happening because everybody's putting in commands. And so what extensions allows you to do is to pull those programmatic inputs out, and then you can actually have a discussion in chat. But if you want to have the extension talking and being a part of that chat conversation, definitely check out the documentation on IRC and our chat bots.
I think I remember somebody did one with like Pac-Man at one time, where they actually did one that controlled it.
There's so many Twitch plays.
It was
pretty
weird,
amazing.
but yeah, I mean, I felt sorry for it because everybody's throwing commands and this thing's like, I don't know what to do.
It's probably Twitch Plays Dark Souls at this point. It has to be.
So actually, to this point, this was something I thought about when I was first authoring this extension too, when I was just learning the moving parts, and I thought, oh, how are people going to interact with the extension? Is it through chat? And then that was before I realized, no, there's, you get your own HTML interface, and that's how all the interaction is going to happen. But something I thought was, well, then if I need to have basically an IRC bot running, then Lambda wouldn't be a good choice for that, right? Because Lambda functions are useful for event-triggered actions. For example, fulfilling an HTTP request, or processing some data that went onto a stream of data, or reacting to a database change. They're not great for long-running processes, and so that's where you might want to look at a different service, whether it's spinning up your own instance on EC2 or Elastic Compute Cloud, or maybe using making a Docker image and running that on one of our Docker container services like ECS, Elastic Container Service, or others.
Well, speaking of
But
that,
I didn't have to do that.
Speaking of that, though, are there different, kind of back in the gotcha realm, are there different types of like screens and configs that you have to deal with in this?
Yes. Okay. So do you want to go back to full screen on the primary for code? Let me just quickly show the viewers how I had to configure the HTTPS serving in case that's interesting. So once you eject from a Create React app, vanilla app, you get the scripts that it will start for you. And so inside the start script, this is just when you say npm start, and that's what starts your developer server for you, there's a lot of stuff in here, but luckily you don't need to worry about it. You just need to add in some configuration to the Webpack development server that gets started. And so that'll be the existing server config, and then we'll also inject into that some HTTPS config pointing to a key and a certificate. Now, these I just pointed to take ones that came from a sample extension that I created before.
Yeah, so both in the sample extension and in the dev rig, there's scripts to generate certs.
Yeah, that was really helpful.
In the case of Linux or Mac OS, I believe it'll add to the keychain and everything for you, so it'll register that. And I believe that the requirement for HTTPS, which we'll talk about it later, but really that's cores. Like you have to have HTTPS on both the locally serving that file so that you can make HTTPS request via cores.
Cross-origin.
Yeah.
Yep, good point. So the other gotcha, and this is what I thought about. I didn't address this because for the purposes of this stream, it was enough to just talk about building the viewer component of the extension. But extensions, as I understand it, also have, for example, a configuration screen.
Yep.
So, or it's optional, but if a broadcaster needs to configure the extension in some way, then your extension is responsible for also showing some sort of interface for that. And again, Twitch will host that, but that is effectively just more content, more front-end content that I'm giving to Twitch to host, to serve.
Yeah, as an example, if you want to have a stat tracker extension, that's where the browser would indicate like what their League of Legends summoner name is, and then you can actually link it to a service.
Right.
Additionally, there is the live config panel, and this is a place where if you want to have a broadcaster-specific config panel on the dashboard, you can put that as a separate view.
Mm. And so we're not using either of those cases for this extension, but I wanted to build for that in mind in case I needed to add those later, or in case viewers wanted to add those later. And so if I quickly just show, with Create React App, it gives you an index.js out of the box, and it's a lot less complicated than this. But what I decided to do was just add in something that will fish out for a parameter in the URL query string. In this case, I decided to call one called view. And if we have one called view, if it's undefined, or if they don't pass one or whatever, it's just going to load my viewer view, which is just like the example extension front end. But you could add ones here. You could add other switch statements here to render different top-level React components for those other cases.
Yeah.
So that was just how I decided if I need to extend this to accommodate the other views, I can still do that with the one React app, which I thought was nice.
Yeah, and it's a great use of that, because when we pass in that query string, because basically this is all served out of an iframe, and you'll have access to kind of get some context when that's loaded from those query string parameters.
Yep, that's what I thought.
Cool.
So I had a question that came in from ShipToast, which was, would it be possible to have a viewer click a button and it give the streamer bits from the viewers?
Not currently. We are working on all sorts of things around bits. And so we did just recently...
Want to explain what bits are? For people?
Yeah, okay. So real quickly, bits allow you to actually cheer for broadcasters. They are basically a monetary donation you can make to a broadcaster. We have cheers, we have cheer motes, so you can actually cheer with a capo or cheer with a PogChamp. And that's a way to support broadcasters. Additionally, we now have extensions that can have bits-enabled purchases. So basically, you can register actions in an extension, where the viewer redeems bits for an action, and both the broadcaster and the developer get a rev share of those bits.
That's very cool.
We are working really hard, actually, on doing new things with bits. So kind of like what you described, we're not there yet, but we are working on it.
So since we were talking about some of the render UI pieces for the broadcaster and the viewer, we had a question from the Freak, which is, can we take a moment and just cover components versus overlay versus mobile?
Yeah, absolutely. So we actually just launched, multiple views or dynamic views for extensions. You can actually create a component extension. So what this does actually, there is a limitation that you can only have one overlay extension installed on your channel. And so this allows the broadcaster to set dynamic component areas, basically anchors that they can put multiple components on the overlay. And when you actually highlight over the component, you can see the area that extension is rendered in.
It's kind of like a little portal to a part of my overlay.
Yeah. So you can have quadrants with different extensions installed.
Very cool.
Yeah, so it has a lot more dynamic. Now, we also launched the ability for mobile extensions. When extensions first launched, it was only available on the website.
Right.
And so now, with the mobile app on Twitch, you can actually bring up and click on the puzzle piece, so you can interact with an extension on the phone. There's all sorts of new uses for that, and you can actually create a dynamic anchor extension. So your extension can be any combination of panel, overlay, or mobile.
Just a question about that.
Yeah.
For mobile, as an extension author, am I still just authoring the same way as I would for the web? Is it still just running HTML and JS? And
Yeah. So it's
mobile?
the same technologies.
Great.
You're actually just specifying the specific views, and then also. For the case of if you want a component or panel extension, you would just have, if you're using a framework like React, it's already going to do a lot of that, sizing work for you based on it.
Yeah, cool.
So I'm going to grab one more question that's actually in regard to where we are in context, which is basically, is there support, and this is from the Jackman, is there support for hidden extensions, things that specifically are for a broadcaster to utilize and interact with the stream itself rather than the viewers?
That's an interesting thought. There's not currently support for that because, technically you could have an extension that the viewer will always see, like a puzzle piece or something, like you could not expose an interface. But I'd definitely love to hear more about like some ideas for that kind of thing.
Awesome. Yeah, so the more feedback you can give and things like that, that helps the community as a whole.
What's the best way for that viewer to send questions or feedback to Travis?
Yeah, so I'm, I think my Twitter handle's on there. Feel free to hit me up there. And also, I'm Travis the OJ on Twitch, so feel free to chat on there too.
Very nice. So, I guess taking for a moment now, we've talked about all kind of front end stuff. So, but obviously we know there has to be a back end piece as well.
Right.
If you could perhaps show some of the first stuff that we would want for how the front end and the back end will correlate, and then we can actually talk about what it is. So what is the element between them?
So I haven't actually shown any of the interesting front-end code yet, so maybe we should just start there real quick.
Yeah.
And then I'll stop at the point where we have the front end making a call to communicate with the back end.
That's perfect. So why don't we go full screen on the primary?
Yep.
So you can walk through some of the code, and yeah.
Okay, so looking at this sort of from the bottom up, and apologies if this doesn't look like stock standard React. I was just kind of sketching as I went along, and I've cleaned it up a little bit, but not a ton. Of course, what developer feels great about their code at any given point. At the end of the day, we have this viewer view, as opposed to other views we might have in the future, like config view or live view. And so for the viewer, we want to render broadcaster controls, raffle status, and any raffle winners. And I just split those up into separate components. And we also depend on a JavaScript file that we pull in from Twitch, and that's what's going to let our extension subscribe to messages for each of the viewers when my backend wants to publish something out. Let's look at broadcaster controls, because the way we're going to kind of trace through this is the same way that I ran through the demo before. The first step is creating a raffle. So how does that work? And so if we look at our broadcaster controls component, it's really as simple as saying, if we think we're the broadcaster, if our state has that, and I'll cover later how this gets set to true, then we'll render a few buttons, right? And our buttons are just going to have start raffle, pick winner, finish raffle. So, what does start raffle end up doing when we click that button? So, start raffle is going to just basically delegate that responsibility of figuring out how to start raffle to this EBS object, and there's a start raffle method on that. And then once that's done, it logs something to the developer rig, in this case, created raffle with a particular ID. So this is just me cleaning up my code instead of having the HTTPS service call right here. I decided to consolidate all of that stuff inside one place. And so if we go to the top, you can see that EBS is really just a instance of whatever this EBS is, which I pull from my EBS API. So again, extension, backend service, not Elastic Block Store. And so if we look here, this is where you're going to control where your front end is going to end up calling. For right now, I'm just going to call it down to localhost on a specific port. And if we look at what it was doing, it was calling start raffle, which is just going to basically say, make a post, an HTTP post to raffle/create to whatever the base URL is plus this path. And this is just me implementing some nice syntactic sugar on top of the HTTP fetch API inside the browser. So that's how we make a request. But you'll notice something interesting here, and this is, I guess, where I'm going to hand off to you guys to talk a little bit more about JWTs and authentication. When your extension communicates with a backend service, you probably want to authenticate those requests to make sure that they're actually coming from the extension. Yeah, I mean, if you definitely want to. I can't see a reason why you wouldn't, except for maybe if you didn't understand it, and hopefully after watching us talk about it, you'll understand it. But in short, the Twitch extensions communicate with JSON Web Token, or JWT, and I'll let you guys talk a bit more about that. But basically, you just need to pass that token off to your server, and then your server is going to validate that that token looks correct before it responds to whatever command it received.
So let's talk about JWT for a second over here on the couch. Travis, what is JWT?
Yeah, so it's a JSON Web Token. It's basically a way to package up JSON and a payload where you can actually verify the sender. So it is a claim between two parties, and you're using a securely hashed, you're using a hashed JSON signed with a shared secret. So when you create an extension, we talked about it a little bit when we went over the developer rig. One of the things each extension has is a shared secret for you to securely negotiate between your front end and your back end.
Interesting. So where do I find them?
So the actual extension secret is found in the dev.twitch.tv developer portal. And using that secret, you can actually you can learn more about JWTs at jwt.io.
Yeah, it's a great resource.
Yeah, it's a really good site for most like technology stuff is pretty sparse, but that place has a list of libraries in multiple languages. It has like a test harness where you can paste in a JWT and you can actually see the header, the payload, and you can even verify the signature. So it's a really good resource when you're developing.
You also maybe want to touch on, to stress, a JWT is not it's not encrypted, right? It's just information that happens to be signed with a shared secret, and that's how you can verify that the information coming inside the JWT wasn't tampered with.
Yeah, exactly. So anybody can look at what's in a JWT. What a JWT does is it verifies that the sender is who they say they are. So essentially, in the case of extensions, when an extension is loaded up in a browser window, there is a callback called onAuthorized. And in that callback, we give you a token that is signed by Twitch. And it is for the purpose of providing secure communication for your extension.
Do you want me to bring that up on the screen while you're talking
Sure,
about it?
yeah, that'd be great.
Definitely, just do on screen with that. And the funny thing is that where do I put them, by the way? So where do I put these?
So you don't actually have to store your JWTs. Like they are used to verify the transmission. So when a request comes in with a JWT in the header, you will ensure that it is verified, and then you can process that request accordingly.
Are there any other things that I would do with a JWT?
Yeah. So JWT is not just the authentication mechanism for front end to back end communication. It is also used for your backend to talk to the Twitch API through certain endpoints. So, for example, we're going to talk about PubSub a little later on and how you emit state changes to your front end through PubSub. If you want to do a broadcast through a Twitch API call, you would sign a JWT yourself. So, an extension developer, you kind of get used to both verifying and signing JWTs.
So, what are some of the gotchas? There's always gotchas.
Yeah, there's always gotchas. So,
technology.
one of the things is make sure you check out our documentation on the JSON Web Token schema. And like if you're putting together the token to call the broadcast endpoint, there's a lot of different fields in there that you will have to make sure that are followed the right way. Once you get that actually created properly, that broadcast call should function properly. But if it's, you can take your encoded JWT, paste it onto jwt.io, and then you can kind of do some debugging there just to make sure that your JWT is being signed properly.
Nice.
And even that little step is super helpful, right? Because when you look at a JWT, you won't be able really to see anything. It's not human readable. Yeah. So I think that's where it's confusing between it's hashed versus it's already encrypted, right?
Yeah.
So you look at this string and you're like, oh, some sort of encryption happened to it, and it's not. It's just not human readable.
Mm-hmm. So there was a question that came in. It looks like you're using the stream overlay rather than using the live config page for the broadcaster only functions. They were wondering why.
Yeah, so we could definitely do the live config panel, and that's probably something we could put together on stream or whatever if we want to. But really, it was the sake for simplicity, so that there was a single view on the front end that you're putting out there.
Yep. No, I mean, I think part of that just comes from my relative inexperience as a Twitch extension developer. I thought the live config was not, I didn't think that was a good use case for it, but it makes perfect sense that that's exactly what you would use it for. I thought it was more for config and not necessarily for interacting with controls that you would want to change at like stream time. But yeah, that makes perfect sense.
Well, I guess,
Great point.
so we've got kind of some of the Hello World sample stuff. So, and you were talking about how you took that and kind of re-geared that. And so if you want to pull that up in full screen and talk about some of the things you threw away and
Sure.
And some of those, we can start with that.
Yeah, sure. So the back end, so let me just pull up, if you look at the developer rig back in the GitHub page, they'll mention that there's a sample extension you can use to get started. And so I started by taking their sample extension, getting that running, just as a sanity check, right? And what's the best way to learn? For me anyway, it's to see running code that already works and then make changes to it and see how those changes affect it and figure out what you need, what you can throw away. And so here in the section here of the developer rig, GitHub page, there's loading a sample extension. And so there's even a command to load that extension for you and clone that repo directly from the developer rig. But if we just look at the extension on GitHub, it's a Hello World extension on the Twitch dev account. And what this extension does is it gives you a button that cycles a color, right? So there's a little circle that starts out the Twitch purple, which I really liked. That there's even a comment saying, here, well, let's look at the code. So if we look here at the front end code first, for example, we can see here that what it starts with, and here's again, just as an example, unauthorized is that callback that the Twitch extension will call out or make available for you and call to once everything is loaded. And that's where you'll want to remember your token so that if you're going to make any calls to the back end, you pass that token along. And so that's even how I learned about that was I just started with the sample extension and went, oh, that makes sense. Cool, so I'll just port that over. And then you can see here that what they're doing is basically, and this is just using jQuery for folks who are more familiar with that than React, then this might even be a better place for you to start than looking at my code. It's attaching a click handler to a button that says cycle, and then basically it's going to go ahead and make a request to set the color. And when it hears a message, a broadcasted message to update the color, it'll go ahead and call its update block color handler. If we look at the back end for this, though, so for the sample extension, the back end's here. So here we can see, let me just search for this, purple. There you go. So see their initial colors, I suppose it's the Twitch official, bleed purple.
That is the marketing sanctioned color code.
There you go. So the way the sample extension works is very similar in that there's a call that's made to say, get me the current color. Yep. And then whenever somebody tries to change a color, let's see what's gonna fire. So you'll see that there's a color cycle handler that we can see who decides to call that. There we go. So if somebody makes a post to /color/cycle, it goes to the color cycle handler. And what that's going to do is, again, it's going to verify and decode that JWT to make sure it looks legit.
Right.
And if it is, it'll continue on. It's going to pull some interesting variables out of the payload using some JavaScript object destructuring. And then it's going to, you can see that the extension maintains some state, right? So this extension keeps track of which, I guess you could run it in multiple channels if you wanted to, this is a nice reference there too. And it's doing that using this channel colors, which is, if we go to the top, it's just a JavaScript object that this extension is using to maintain state. And that works here because this extension's, the spirit of it is to be running as a long running process, right? That you might just start up and leave running. But that wouldn't work for my case with AWS Lambda because each Lambda invocation is meant just to fulfill that one HTTP request and then it goes away.
Right.
So that's why for my extension I had to introduce some kind of state store, and that's where I chose to use DynamoDB.
Okay. So I think what's really cool about this, the Hello World example, is it's the smallest possible way to illustrate both communication methods between the front end and the back end. You've got an HTTPS, AJAX call to make front end to back end requests.
Yes.
But then you also have PubSub that's communicating state changes directly.
Yep.
So when somebody clicks, give me a new color, that's a call to the back end. Backend broadcasts the new color to all extensions.
And let's look at that broadcast again too, because it touches on something you talked about before. There's some other good practices in here that I stripped out for my code base, but I like that they were here as a reference.
Who needs them?
I like that they were here for reference, although I find that sometimes there's a balance between including code because it's a good practice, but then also it's more cognitive load for somebody who's coming to this code for the first time to get their head around.
Yeah.
I liked it because it was clear to me what was going on here. I did strip it out for mine, but what the Hello World color cycle extension also includes is some kind of rate limiting, which it's a good thing you might want to consider inside your extensions as well, right? Just as general advice.
I would like to pause here and talk about scale. So there's a thing about Twitch scale, and building an extension is really important to consider the scalability of that extension as well. Because on Twitch, things can get very popular very quickly. If your extension is installed on a channel where Drake visits, you want that extension to continue running. So basically, serverless is a great way to handle the first level of scalability. You can even go a step further and you can have auto-scaling groups with EC2 behind elastic load balancers. There's many ways to accomplish scaling, and coming up with a truly scalable extension, you have to kind of be mindful of both the back-end communication and making sure that your front end can gracefully handle those 429s. So that is definitely a consideration when building an extension, that scale can change quickly.
Yeah, and just to touch on that a bit more, I think Lambda is a great choice when it comes to scaling this type of thing because it will scale for you. You don't have to think about setting up auto-scaling groups if you're running an EC2 server, for example. But again, it comes down to what's your comfort level as a developer. If you're more comfortable using EC2 already with a virtual server, there's nothing wrong with that. But Lambda's nice because it'll scale, right? You have more requests coming in, they'll probably get fulfilled.
Yeah. There's some cool, what's
cold
the
starts?
term? Cold starts is one thing to be aware of with Lambda functions.
Yeah.
Normally you shouldn't hit up against that because if your extension is receiving requests regularly, but if all of a sudden your function needs to be run on multiple instances, at the back end, as it scales up, those cold starts can make those requests be a little bit longer for a short amount of time.
Yeah. That said, different languages have different cold start characteristics, and the JS cold starts tend to be a lot faster than, say, the JavaScript cold starts. I'm sorry, the Java cold starts. Java cold starts.
Let's say cold starts.
It's a good tongue twister.
So,
So I guess, do we want to start with, let's take a look at the first building blocks of actually creating this raffle.
Yep.
Yeah.
So let's go ahead and dive in I guess we'll start with the handler.
Yeah, sure. So we kind of already talked about how the front end makes a request and that it needs to include that signed JWT. How does the back end do it? So let's pop back into my code here on primary, and we'll look at the back end now, which is inside a different editor. Okay, so my API on the back end, if we look at this section, well here, let me show you one, before I get into the routes and the handlers, one refactoring I did was in the sample extension, you'll notice that every handler at the top of it is verifying the JWT. And that's a great thing you should do, but I get a little twitchy, no pun intended, about code duplication at parts, especially if I can figure out a way to clean that up. And the example extension backend is written using HAPI or Happy, which is a nice Node API package. And one of the things that Happy gives you is the ability of defining an authentication scheme and then registering that scheme as sort of the default handler that should, or default authentication strategy that should run for all of your requests. And so if you can just encapsulate all of your JWT checking code directly, you can register it that way. Now, there are already JWT published schemes out there, so I didn't have to make a custom one, but it was very easy for me to take the existing code that already existed in the sample, call it a custom scheme here, and just refactor that out. So I didn't have to remember to authenticate every request in the handler level. That was getting done in the framework level for me.
Yeah. Another cool way you could do this with API Gateway. API Gateway supports authorizer functions.
Yep.
And so you can actually have a Lambda function that is set up solely to be your JWT authorization function. And using whatever serverless SAM, you can actually specify which Lambda functions all have that custom authorizer that's called first.
Yep.
There's still a little bit of overhead to learn because basically that function has to return an IAM policy, and working with defining your own programmatic IAM policies is fun. IAM is the
Identity and access
yes,
management.
thank you,
There we
man.
go.
I haven't been at AWS for years, so I'm
brought
still
one of those guys.
yeah, exactly. It's AWS's authorization policy management for how all of its services talk to each other, and so that would actually be where that JWT is representing that user, and you are tying together the IAM policy for that token on what Lambda functions they can run.
Cool. So again, just to type back, I stuck with the example code because again, it was less of a departure from what the example extension had, and I liked leaving as much of it there as I could and just changing what I needed to. But we can see I have a section here where I define different handler functions for my different routes. So if someone makes an HTTP post request to Raffle's create, it goes to my create raffle handler. And the create raffle handler is pretty simple. Again, I think most of your handlers should be designed to be simple, and all your logic shouldn't be inside your handler function, but appropriately delegated elsewhere, so that all the code here kind of operates on a same level of abstraction, I think. I mean, we could probably make it a little cleaner, but we instantiate a new instance of this raffle object, whatever that is, and I'll show you that code in a minute. And then we ask our raffle store to go ahead and save that raffle, and this is just my state store. And then finally, we're going to broadcast out to the channel an event called raffle started with some information about the raffle. And so just if we quickly unpack this by going one level deeper and looking at where these come from. So raffle and DynamoDB raffle store, or I should say raffle store, which you didn't see yet, is an instance of the DynamoDB raffle store. So where there's just some configuration set there. And that's just me trying to follow some good programming best practices where the API for how you interact with your state store stays the same depending on your implementation. Like that's up to this to provide a particular API that works with, in this case, DynamoDB. So raffles and raffles in the store are both here in this other file. And basically my raffle is just something that's going to keep track of participants. Its ID will just be a unique UUID that gets auto-generated, and it'll keep track of winners. And I chose winners to be an array because I thought, wouldn't it be nice if you could pick more than one winner? Say, for example, you want to lead a Diablo boss run, and you want to have 4 viewers come with you, or I think 4 is maybe the max in the party in Diablo, isn't it? So maybe it's 3 viewers come with you. It's been a while since I played Diablo 3, but
shame on you.
You could pick more than one winner is the point here. And so that's all that raffle does here, and I probably shouldn't have called this to JSON because it's not a JSON string, it's just an object representation. But the point here was this is effectively what's going to get used to be serialized in DynamoDB. The DynamoDB store in its case is really just using the AWS JavaScript API to talk to DynamoDB. Now this is probably a good time to pause and say what is DynamoDB and and work with it, or do you want to talk about that later?
Well, no, I do want to talk about that when I get a few other pieces with it. One of the things that I did want to make sure that we did cover was kind of, a little more, there's 2 points I'm going to go over, and that is a little more in depth on the extension backend service and some of the pieces with that. And then the other thing is kind of that, we're talking a lot Lambda, right? And from an old
Isn't that
movie.
the Revenge
Yes,
of
it
the
was
Nerds
Revenge of the
fraternity?
Nerds, baby.
All right.
But I think I want to ask that question first, and that is, how do you really scale that up? I mean, does it have, like, when you get above 10,000, 20,000 per second, like, how do you really handle if all of a sudden, Ninja, pulls it out and this thing's just getting blasted, right? How are the ways that we do some of the scaling on that? Any thoughts on that?
Yeah, I think from an AWS perspective, that might be more on you to handle.
I believe that there is a soft limit, maximum number of concurrent Lambda invocations that each account can support. I don't remember what that number is off the top of my head, but it's something that is relatively high.
Okay.
If you're approaching whatever that number is, I don't know that you'll find out ahead of time by AWS letting you know or not, but at some point, you're probably going to see an error saying max number of invocations is reached. That number is really high, by the way, and these Lambda functions take milliseconds to fulfill. So it's likely not going to be a problem until you're at massive, massive scale, like you mentioned. But at some point, you will. Those soft limits can be increased. You can make requests to AWS through the support functionality and say, I'd like to be able to run more concurrent invocations.
Is there a CloudWatch metric for that?
There's probably, like, max invocations reached. There probably is. I don't know.
Or just total number of invocations. So you can
So it's really,
I suspect there's definitely a CloudWatch metric for that.
Yeah.
so if you're running into that and you're starting to see that because you're just massive, the reality is just send a message and say,
Yes.
hey, I need to be boosted up, and problem solved.
Just to talk for a second about Lambda at scale, there are a number of very big companies using Lambda at scale. One that I like to mention is FINRA, the financial regulator for US. They do $500 billion, 500 billion market validations, market event validations per day. So on Lambda, using Lambda for this. So there, you can do massive scale with Lambda.
You realize everybody just whipped out their calculator.
Yeah.
Right, just a number
How many per second?
Yeah.
That's a lot.
I'll do that with
I
change streams.
think another potential constraint you might hit up against is if your EBS is calling out to like broadcast state changes or the API, each Lambda server has a certain number of ENIs.
Okay, yeah, so let's talk about that. Elastic Network Interfaces, or ENIs. Yeah, so if your Lambda function needs to talk to the outside world, not all of them do, right? Some of them can just fulfill, in this case, you might just fulfill an HTTP request by talking to DynamoDB to get some data and then going out. But if you need to talk to the outside world, then you're going to get an ENI or an Elastic Network Interface attached to that Lambda. And there is a limit to how many of those. It's also, that's a soft limit, I think, and that can get raised also. But it's another thing to consider is if your Lambda needs to make outside calls, like it does if it's going to broadcast, there's another area where you're going to need to think about scalability.
So, we were talking a little bit about EBS. I don't know if we really dove into that as much, or did we kind of cover everything you were
Yeah, so EBS is what we call the extension backend service. So when we say EBS, that's just your extension's backend.
Yeah, in this case, it's mine, the code that we've just been looking at. And for example, just to look at the last bit, back in the code where my create raffle handler, it said to the raffle store, please save this raffle. This is just me translating that into DynamoDB speak.
And just so everyone else can see it, let's go ahead and bring that on screen
On the
so you can see
primary.
what we're talking about on the primary.
Yeah, so DynamoDB is a NoSQL database service, and I chose it. You have a lot of options. For this case, all I wanted was a place in the cloud to store some object state. And this raffle extension, it doesn't yet support multi-tenancy or figuring out if we wanted to publish this as a full extension, I would need to put a little bit more work into having it support the raffle, what channel a raffle was tied to, and have each channel have only one raffle at a time, et cetera. But for this case, just starting really simply, I just said I just want a place to store a blob of JSON content that I'll read and update as needed by my backend service. And so that's what's going on here is I'm just stringifying my raffle and storing that state in a key called JSON. And the idea here is I decided to support keying off of different usernames. This is probably better served as a channel ID going forward. But the idea here is at a unique key, you can just, which it calls ID, You can store anything you want. It's a flexible schema, so even different rows or different values, I shouldn't say rows necessarily, but the objects that are at different keys can have different schemas inside them as well. This one just has one attribute called JSON, which is just a string of JSON.
So let's kind of do like where we're at right now. The current place where we're at, and for those just now joining the screen, joining the stream, we're actually doing live coding with an Alexa-enabled Twitch extension. And we're walking through how to actually build it both from the Twitch and Alexa side. And we're going a little more in depth here so people can really understand what's going on behind the scenes. It's also a great reference to be able to work from. We're answering questions live on the stream as well. So if you go in, you can post questions. And if they're in context, we'll do them then. We're going to have a big Q&A at the end so we can answer all kinds of questions from everybody. But just to bring up the speed where we're at now, we're talking about on the client side. So let's talk a quick bullet of what we've talked about so far, just what we've built.
Yep. Yeah. So what we've built is a sample extension to run a raffle on a Twitch channel. And the way it works is there's a front end that's just all Twitch extensions are just web apps, essentially JavaScript and HTML. And this extension exposes buttons. In fact, here I'll recap. I'll re-demo it here on the primary monitor. So here I've got a broadcaster view of this extension on the left and a logged-in viewer view of the extension on the right. And the broadcaster has special controls enabled for them, so they can start a raffle. At that point, what happens is that a message gets published to all the other viewers. They can join the raffle if they want to, and then after everybody's joined, or at whatever point the broadcaster so chooses, they can pick winners. And if your name gets picked, you get some nice confetti, and the winners get shown there. And then when the broadcaster's done, he or she can click Finish Raffle to close it out and start the process over again.
And the idea here for everybody to understand is that you see these buttons that are up on the interface, but we're not actually going to have them have to push the buttons. We're going to get Alexa involved, so Alexa pushes our buttons for us. Now, as for code construct-wise, you know, we've talked about right now, you know, the sampler you started from and creating the raffle, just a handler for it and the piece for that. Obviously, the next part of it, it's got to go somewhere and talk to something else. So, you know, what is the mechanism of where we want it to talk to?
Yep. So looking back at the code, the last part about this is, so the raffle handler on the backend service creates a new raffle and stores it in its store. However, that you don't need to worry about that if you're just tuning in. It's just remembering its state about what the current raffle is, and then it's broadcasting that the event notification out to all of the other extensions that are loaded on the channel so that they can get that message. And you can broadcast anything you want. I'm choosing to just broadcast out an object that represents both an event and any metadata about that event. So I have a nice front-end event handler that will say, based on whatever message got broadcast, what should I do?
But what URL am I hitting?
Yep, so I'm going to unpack that right now. So what you'll see in this broadcast message is, method is, let me go to the definition. So this I took from the sample extension. I didn't really have to modify it at all. And what it's going to do is it's going to put together appropriate headers. And this ties back to what we were talking about before, where if your backend service wants to talk to the Twitch API in order to do something like, say, use Twitch's pub sub to publish a message out to all the viewers, you're going to have to also construct a appropriate token. So we make a token and pass that in with some headers, and you construct your body that says, where do you want to send this message? In this case, broadcast is a special target. That means everyone, right?
Yep.
And then it's going to go ahead and just make that request, in this case using the request NPM module, to a particular URL on Twitch, and then it's going to log the result of the error appropriately.
Yeah, and I should also say, like, when you say broadcast here in this instance, you're sending it to every extension instance that's on that channel, with the channel IDs in the URL.
That's right.
There is also a method to, if you want to send a message to all extensions on all channels.
Ah, cool.
Yeah, so you can do like Twitch global events and extensions too. That was a recent update.
That's nice.
But could we jump into how you make the server token just so we can see the JWT
Thank you.
sign method?
Yep.
Yeah, so really all you're doing is you're creating a payload that is JSON, and then you're calling jwt.sign with the secret. One thing that's important to note is always specify the algorithm here, HS256, and when you're verifying, always look for that algorithm in the verification as well, because technically JWT allows you to put algorithm none or something
Yes,
like that.
yeah.
So you can have a null algorithm. So ensuring that when your backend is doing a JWT verify, ensure that you're using the HS256 algorithm.
Cool.
So something real quick, we talked about EBS and some of the pieces behind that. And I do want to, there was a couple questions that were actually in context that I wanted to address.
Cool.
The first question comes from him, Mike Gimme again. And he asked us for the AWS side. He said, building the EBS on Lambda, what's the best approach to respecting Twitch's one message channel per second pub sub limit in such a mostly stateless environment? They tried SQS for long polling, or pooling, Elasticache and VPC Lambdas, Kinesis and Dynamo streams, and while they all work, everything we tried to see just seemed to be kind of hacky. And so that was one of the questions. There was a comment that somebody did post internally, which was that we can mention that SQS and Lambda integration is coming very soon at the serverless days, which could make the scenario easier. But how else would you kind of address that?
Well, let's hash that out. Here's my sense.
Sure.
The code that the sample extension comes with is a good reference. It's just we can't use that with Lambda because that state is assuming it's going to be for a long-running process, right? Which the Lambda handlers wouldn't be. But I don't see any reason why you wouldn't just move that state. In other words, the timeout limits for when was the last time you published a particular channel. Why you wouldn't just move that to some caching service like Elasticache on AWS, for example, that supports Redis or the memcached APIs, and because you want something really fast in memory as a state store that's going to persist between your Lambda invocations. So I would just store that state there, in terms of knowing if it's safe for me to publish again or not. Or what you could do, and again, this actually probably makes more sense now that I'm thinking about it. Talking out loud is the best way to clarify your thoughts. So yeah, why not just have anytime you want to publish the message, I would just probably put that into an SQS queue. SQS is our simple queue service. And I would just have a Lambda worker that's looking to see, every time something goes onto that queue, it's going to get triggered and say, should I publish or not yet? And so that is what could check the cache and then go ahead and write it or retry.
I mean, if you're hitting up against that frequency of needing to emit state changes more than once per second, it really depends on the type of extension, the experience you want to build. And it really is one of those points where there are methods to kind of either batch up or aggregate state changes, and it's a combination of the frequency limitation, which is 1 request per second, and the payload size, which I think it's either 1 kilobyte or 5 kilobyte. I need to look that up. But in conjunction, those are the boundaries you have to. Those are kind of the design constraints. And I think it's really just designing a solution that does that aggregation dependent upon what it is your extension needs to do.
I like your point, though, that here I am sitting here thinking, okay, what's the best way to stitch these services together? And you've zoomed out a little bit and said, well, maybe you should, instead of trying to figure out how you're going to broadcast, more, or how you're going to wire up it to broadcast exactly once every second in the best way possible, why don't we think about, can we aggregate? Can we do this a little more elegantly? I think that's a good point.
Cool. Lots of different ways.
Yeah.
Very sweet. So let's kind of jump into, we were talking about what's the URL. And you mentioned before API gateway, and cores and CloudFormation, some of those things. Tell us kind of what all these pieces are that we're dealing with to actually do this.
Sure. So that's probably a good time for me on my primary computer here to pop open this template.yaml file that I have. So
just on screen.
On screen here, yep. So what you need to do if you want to have an API served by Lambda is you're going to have a Lambda function that's going to handle those requests, but you need to use API Gateway, which is the AWS service that will basically trigger Lambda events when it gets HTTP requests for you.
Do you have to, or should you?
You have to, in the sense that Lambda needs something to trigger it, and your Lambda is not always running, and so API Gateway is a service that will always be listening for HTTP requests at a particular URL, and then it's going to pass those on as events to your Lambda if you configure it that way. So API Gateway and Lambda are like BFFs when it comes to building APIs. That's why it's called API Gateway. It's made for this.
It's like a router to your functions.
Exactly.
Got it.
And you can set all of this up manually by hand in the AWS Web Console, but because this is a very common deployment scenario, There are tools you can use to simplify that and to automate it, which is good for repeatable deployments and also just to make sure that you've got everything lined up and you're not forgetting to do something. Now, CloudFormation is it's a tool, it's an infrastructure as code tool that AWS provides that lets you specify a group, lets you provision resources in AWS using a JSON or YAML syntax. And if you've heard of Terraform, it's similar to Terraform in that it's a different strategy, but it's a way to express, here are the resources I need for my system, please make it so in the cloud. But CloudFormation is also very verbose, and that's not necessarily a bad thing at all. It's very good, it's very specific that way. But because, again, this is such a common pattern of I have a Lambda function, I want to front it with API gateway with these particular URLs, we have a DSL, or domain-specific language, on top of CloudFormation with a tool called SAM, the Serverless Application Model. And you can learn more about that by looking up AWS SAM. And SAM Local is a tool that will run your serverless functions locally on your machine for development purposes. What I have here is a SAM template that very concisely lets me say the following. For example, I want my API to support cores, and I'm being very permissive here and just saying allow everything through. Obviously, in production, we would want to lock this down a little bit.
What's cores?
Cores is cross-origin resource sharing, I think.
You got it.
Wow, not bad. This guy knows it.
know my T and FLAs. So it is a security mechanism in the browser where if your browser is going to make a AJAX call to another domain, first what it'll do is it will make a call to whatever URL it's trying to load with the options HTTP verb to make sure that that looks right. And it's going to send in some headers along with that and check the response. And if the response looks right from a course perspective, then it'll go ahead and make that request.
Yep, that's right.
And so you can tell API Gateway, I would like it to support cores to pass the appropriate cores headers on for my stuff with this very nice, concise syntax. And then here I'm just simply saying, all right, I'm going to need a DynamoDB table, which I'll call Raffles table. And this AWS serverless simple table is, behind the scenes, it will resolve to a DynamoDB table. And I tell it that I have a primary key of ID, it's type string, and I can give it some default provisioning throughput. 3 is completely fine for the demo purposes here. And then here's a real interesting meat. So I say I have an API function, and here's where to find the code that's going to power that inside my directory called source. Here is the appropriate handler name for it inside whatever file it's in. It should be Node.js 8.10, etc. I'm giving it full DynamoDB access. It's okay. These secrets are okay in the sense that this extension that I'm running with right now for demo purposes isn't published anywhere. Right. So I don't think we're really exposing any dangerous secrets here.
No.
But the point is,
be careful with your secrets. Folks.
Yes, be careful with your secrets.
Don't put them on Post-it notes.
Generally, don't put them on Post-it notes. But I'm exposing some environment variables to my Lambda function so that it knows the appropriate secrets when it's going to, for example, sign its JWTs that it makes. But here I just express in a nice, simple way that I've got a couple different endpoints, and here are the methods and paths that they should support, and it can capture parameters in the URLs as well. And with just this, that's all I need to do in order to get API Gateway stood up with a Lambda deployed. And there's a command you can use to deploy this. It's actually 2 commands. One is SAM package, where you give it a template file, and then you tell it where to put it, and an S3 bucket to put it on, and force upload if you want to overwrite it. And then another command, SAM deploy, which takes the package template file and what stack name you want and what region you want to deploy to. And what you get out the other side, and this is probably just worth showing. Let me go up to CloudFormation for a second. Because at the end of the day, SAM just outputs CloudFormation. You get a CloudFormation stack. And the nice thing about this is, in its output section, it tells me what did it provision for me. And one of the things here is, what is my production URL for the API gateway endpoint? So that answers
my question.
Exactly.
Where did it go?
Where did it go? So that's where you'll notice just back in my front-end code, I have one piece of code here that I've just been toggling for when I'm developing locally or when I'm testing for what the base URL is of my backend that I'm posting.
Got it. Yeah. Okay, that makes sense.
You can also, with like Certificate Manager and Route 53, you can map that to like a meaningful domain name. Right? Yeah.
So it's
Yes.
just, when you're starting to build this, if you really kind of use this up front, it makes it really easy because you can just keep stacking more
If
different
you have
calls
more
in there,
resources you need to make, if you need to just add different URLs to handle,
Right.
it saves you the trouble of having to go into the console, the web console, and manually click on a bunch of things. And it gives you a repeatable deployment. So if I wanted to deploy this into another AWS region, because I have this already written out in a nice template file, I can deploy globally in seconds.
Nice. Very nice.
Yeah.
Very nice. So, you know, one of the things you were talking about is kind of like a state store, and you kept saying DynamoDB. I
Yes.
mean, so let's kind of dive a little bit into that. I mean,
Sure.
you know, so tell me, you know, first of all, for those who aren't familiar with it, you know, what is not DynamoDB, and why did you choose to use it?
Sure.
Choose to use it.
So
Choose.
looking at the DynamoDB service page here on AWS, it is a non-relational database service for any scale, and you're only paying for the throughput and storage you need. Practically, what this means is it's a storage service that lets you say, I want to read or write a particular key, and it supports batch operations as well, and you'll get back and you'll get back whatever you've stored at that key. Right? It's like an object store, except you can do some more expressive operations. It's not just get at a particular key or update or delete a key. You can also do scans on tables. So walking through and just getting all the records, or you can do queries, and you can say, I want you to look at your index and only give me records that match this particular value. It supports multiple indexes too, something it calls global secondary indexes. So with DynamoDB, you are specifying this is how I want this is the key that I want to use for all my records. And if you effectively want to be searching by multiple keys, that's a case where you want multiple indexes. And so you can create multiple indexes to let you have more expressive searches on any of those other attributes that you might have in your table.
So I guess one of my questions is that, like we've said DynamoDB for a lot of stuff. Do I have to use DynamoDB?
Not at all.
Like, am I locked in here?
No, not at all. I chose DynamoDB because it's a very simple API to work with, and I didn't have to think about provisioning a lot of other things. For example, I could have chosen to use a relational database here. That would have been fine. I think it comes down to both what you're familiar with and what's going to scale well. And I also wanted to use DynamoDB because I thought it's quite a scale. It's a very, very, very scalable service where response times come back in milliseconds, that like by design. You can also get your response times down to nanoseconds if you need to, using something called a DynamoDB Accelerator. It's another
DAX.
service that we have, DAX.
DAX.
Yeah,
Yes.
DAX is super cool.
DAX is sweet.
So it's a read-through and write-through cache that sits in front of DynamoDB and can make your responses up to nanoseconds instead of
It's like the SSD
or
of your hard drive.
microseconds or nanoseconds. I forget which. I think it's nanoseconds. Yeah. So it can make them really fast.
Yeah, it's really
Not
fast.
picoseconds.
Yeah.
Just really,
Much
really fast.
much faster than they already are, which is very fast.
And DynamoDB and Lambda kind of work well together. Also, like, doesn't Lambda have some extra connection pooling stuff with DynamoDB? Like, it'll manage that stuff for you.
I don't know the answer to that offhand, but
Okay.
that's probably true.
I think I heard that somewhere.
Okay.
So we've started out here. We kind of, we built up the first part. We've got the handler. We've talked about some of the pieces. I really wanted to make sure that we covered a lot of the basic elements of why we're making some of these choices and what we're doing. Let's go ahead and work through the rest of it. Kind of, let's put together, entering the raffle. Let's finish up for how we pick. Let's kind of burn through some of that stuff. And these
Sure.
are kind of review steps, but
Yep.
yeah, let's go ahead and tear that apart.
Okay. So we covered creating a raffle and seeing the backend service broadcast out an event to the front end to say a raffle had started. What does the front end do to respond to that, right? Well, you can see here, when my component mounts in React, this is just the right place for me to load anything that I need to do on initialization. I ask Twitch to call me back with this function for when the Twitch authorization takes place. And at that point, I know my token, which I can use to make further backend calls. I'm also going to call a function to load my initial raffle state up. This is just because, and we'll kind of come back to this at the end, but I want to know who am I, like what my user ID is. I want to know what if there's a raffle already running when I first come to a channel, so my extension can start out in the right state. And finally, here's another thing where I'll register a callback function to say, for any broadcasts that happen, what do I want to do? In this case, I'm going to fire my handle message handler, where I just parse out the message because I sent it as a JavaScript object, which gets stringified, passed over the Twitch's pub sub. And handle message is just really simply going to just do a simple dispatch for figuring out what should it do based on what event type it was. So in the case of raffle started, I'm just going to set state and populate the raffle ID for this component. Now, because I'm using React, I chose React because one of the things that's really nice about it is it makes redrawing the UI very simple for a given state. And with jQuery, I would have to wire up a lot of if statements or remembering well, if the state is this, dispatch this. With React, you can just say, here's my state. Please render whatever is appropriate now. Re-render yourself given that current state, right? It's a functional way to think about your components, where they get some state, they react to that state and render a certain way. So they're going to just remember their raffle ID, and at that point, that's what makes the join button show up. So we can see back in our renders, our rendering, raffle status is one of the other things. So broadcaster control, only the broadcasters will see. Raffle status is just going to say, all right, well, if I've got a raffle ID in my state and I'm not joined yet, if I haven't joined the raffle, then we'll show that a raffle has started, do you want to join? And we'll give them the join button. And so similarly, just while we're here, we'll look at the rest of this code. If there's a raffle ID started, if we have a raffle and they've already joined, then just let them know they've joined. And if there isn't a raffle ID yet, we'll say that there's no active raffle yet. And just based on this, that's how we're getting our different behavior back here in the extension where there's no raffle ID yet because I haven't started one. When I click start, the message got broadcast after it created a raffle, and the UIs react accordingly. If you join, what happens? Well, again, it's not going to look very much different than the other stuff, right? My button for join just says, use my EBS object, which just wraps up a nice API call for me to say, join the raffle, given the ID that I was given. And I'll set my state to say that I know I was joined. And I can log this back to the Twitch developer rig if I want to see it. Pick winner does something similar. So when
real quick on the join raffle.
Yes.
One thing that we would probably want to update if we want to flesh this out into like we talked about with the multi-tenant thing, is technically the front end has taken away your ability to join the raffle.
But only from a display purpose.
Right, exactly. Yes. And so using that token, I can enter the raffle as many times as I want.
That's right. So that's a wonderful point. So for the purposes of this particular extension, I haven't put a lot of effort into making it secure or verifying the state that user was already in the raffle or not. However, I believe I'm using a DynamoDB string set for tracking the participant. No, I'm not. I'm using a JavaScript object. Never mind. I was going to say. So one way to handle that without having conditional logic in your code would be to use a DynamoDB string set, which is a particular field type that it's a set, right? So there's no duplicated values. And so if you were just storing the user IDs or the usernames as a string set in DynamoDB, it would effectively be an idempotent operation. And so, it would still cause some back-end chatter, but they wouldn't get another entry into the raffle.
And you can do, I think, conditional writes on Dynamo as well.
Exactly. You could also do something like that.
But just a thought, because
that's a really good point you bring up.
JWTs ensure the sender, but it doesn't protect you from replay attacks. So it's like somebody can take that token and enter the raffle many times.
They totally could. So if we wanted to protect it against that in the back end, what we would do is just have the back end say, are they already in my list of participants for this raffle? If they are, stop or give an error message back.
Yeah.
So, real quick though, part of the model here of what we're doing is that you've got all these things you're talking about, like when it pubs out and when they're talking to others, and that's really with the pub sub model, right? So what would be good is we actually took a moment and kind of jumped into the pub sub model itself, so people can better understand, what we're doing here. And so we'll go over to the couch here and have Braxton and me, we'll kind of walk through some of that.
Okay.
Sounds good.
So guys.
So we have slight technical difficulty.
Oh.
No longer mic'd up.
You're not mic'd up anymore, huh?
Matt lost his mic.
Looks like
Looks
like
tag team.
You can just yell into my shirt.
you didn't think everything was going to go perfect, did you? Yeah, be friendly.
Well, hopefully you can hear me. But, we've really danced around and talked about PubSub throughout this whole thing. PubSub is what allows, the extension to talk to the backend and then broadcast messages back and forth. So I know Gabe talked about it. I know Travis talked about it. Originally, the backend is communicating that message to what he specified as everybody who is watching that channel. So we're broadcasting to our subscribers, in this case, is everybody that has the extension displaying to them. So that allows us to say, hey, let's render this button on everyone that has the extension enabled. And it also the same thing going the other way, where if they click the button, it basically says, hey, somebody clicked this button, we would like to communicate back to that person and say, all right, you clicked the button, so now you send the message and you've joined the raffle. And people also know PubSub for other subscription topics like subscribing to a Twitch broadcaster, bits, donations, all that stuff, followings. We've all seen the pop-ups when we're watching a stream. But that's really PubSub, at its core. And that also works with the Alexa part because that has to communicate to the back end and say, broadcast messages of this person has entered the extension. So not only is it saying in the UI, hey, you've joined, well, the Alexa part needs to read that back in and say, okay, this person has joined, which it sounds like, we use DynamoDB for that. But yeah, it's TLDR.
Are there, so I mean, are there any limitations or transactions or anything that we kind of,
There are. I'm going to let Travis keep me honest on the limitations. I know there are limits.
Yeah. So we've got a frequency limit. You've got the number of messages. It's a 1 request per second, like per channel. And then there is the payload limit, which I believe is 5 kilobytes. So that's the total size of the payload.
Okay. So now, I mean, are there, with what we're doing in here, I mean, does that really encapsulate kind of everything that you'll do in PubSub? Or are there things that you should use it for, shouldn't use it for?
I don't think we even mentioned really like what PubSub means, right? So
Well, there's a great idea.
So it's PubSub, it's your publishing and subscribing, right? It's a model where instead of just broadcasting something and letting the client say like this message pertains to me, you as a client, you say, okay, I want these type of messages from this specific broadcast. So that's how you can fan out, right? Something where it can go to a bunch of different clients. It could be really specific for a few clients, and you can layer things on top of it. So it's more of a way of thinking about the messages than specific just technology.
Mm-hmm. Yeah, so you definitely need to edit that based on your use case. And you hear a lot about the other way, as I mentioned, where you can listen to topics, subscriptions and donate bits, cheers and followings, all that stuff.
So really, you can kind of you can take a particular subscriber that you want to only, if you're talking about bits, and you only want certain things to actually be able to react to that.
Right.
You'll put them on as a subscriber, even though you're publishing out, across the board. It's just going to pick them up. So it gives you a better way to kind of isolate different code pieces. They're not firing off and everything trying to decipher every single message.
Yeah, despite like Travis mentioned earlier, you might have something that you want to have like at Twitch level, right? Like Twitch might want to do that and just let everyone know.
I love that term, by the way, Twitch level.
But you probably don't want to let everyone do that, or you don't want to send messages to everybody and then have them decide. Like you would quickly flood the network with just all the messages going back and forth. What you want to be able is like keep it lean and just say, okay, here's a message, the right people are getting it, they're subscribed to the right topics, or the right pieces of software. Because again, if we're building everything on Lambda and everything is microservices, some services might care about things, some services might care other things like authentication or the raffle or whatnot, right?
What I guess you would say, what are the gotchas in PubSub that you've seen, or you've seen people try to do, implementing it right, implementing it wrong? What are some of the things that you might have seen in that model?
Yeah, the biggest thing I would say would be the limitations that Travis mentioned. As we got a question in the chat earlier, that depending on your use case, that can be difficult to account for, especially depending on what backend service you're using or what Lambda functions you're using. That's probably the biggest thing we get. But it all goes into the architecture of your whole application, your whole extension as well. It just depends on what you're trying to do. You might be able to make up for that in a different way. I'd say that's my 2 cents.
Yeah, and right here, like when you said architecture, it kind of triggered something that I wanted to mention is that we're choosing certain things or certain technologies or certain stacks, if you want another buzzword, to do ways and to do certain things, right? Like Gabe wanted to do React and he chose Node on Lambda, but none of these are. We're not saying to you this is the only way to do it or this is the perfect way to do it. There's a lot of architectural and design decisions that go into that. Some might be related to what you're comfortable with, what you know. Some might be related to scale. So it's important to understand that we're not saying this is the only way to achieve this. This is one way to achieve this, and we want to share it with you, but there's many, many, many ways to do it.
Yeah, kind of like our comment earlier about the legalities of raffles. Obviously, we built something that uses a lot of different technologies that are all awesome. But it's just an example of ways you can build things. It's not necessarily this is the best way to build a perfect instant raffle to give reward, let people play with you or whatever. Yeah, just a demo, just a really cool way using technologies.
Exactly, and if the lawyer had been on stream, he'd probably would have told Gabe to like make sure that multiple people are not the same person's not just flooding the raffle, right? Like, just
Well, did have a suggestion on the stream that somebody was like, well, how about if you wanted to rig the raffle?
Yeah, then Travis said, yeah,
Of course you know how.
you always win. It's always the broadcaster.
always winning the raffle.
Yeah.
That's stacking the deck. But so for those just now joining the stream, we're doing live coding an Alexa-enabled Twitch extension. We're walking through how you can actually take both sides between Twitch live feed and an Alexa extension and being able to, an Alexa skill, and to be able to get them interoperate so that people don't have to actually leave the feed. They don't have to leave their game and interact more with the users in their Twitch feed. And we're kind of walking through all the pieces and elements with the different experts here that we have, the developers from both Twitch and also from Alexa, and of course, Game Tech.
Yeah, and I think part of it is there's these really nice interactions between new technologies, right? Extensions are fairly new. Alexa isn't new, but we hadn't really seen this. And we're like, this is a really interesting use case. This is something interesting that we can share with the community. And we just wanted to share, or like push the envelope a little bit. It's part of like the Amazon DNA, how we can take multiple pieces from all over the company and put it into like a nice new package, right?
Yeah, to the topic of pushing the envelope, one thing I want to mention is that like anybody could have done this. Obviously, we all work for Twitch and Amazon. That's Alexa, and that's all great. But anybody can make a skill. Anybody can make an extension. Anybody can use AWS. So or other technologies, whatever you want to do. Point being, anybody can push the envelope and make awesome stuff.
Yeah, there's no secret sauce here, right? Like if you built a skill, you can take Gabe's extension code and mash them together, and now you have an extension piece. If you built an extension before, you can take my code and add voice to your skill. So we really wanted to show you that this is something that anyone can do. It has a few moving parts, but once you get those in your head, it's not that complicated.
So, for some of this also, can you deploy it with Docker?
Yeah, you could do everything that Gabe's hosting on Lambda, move it over to Docker. We haven't gotten to the code that's powering the Alexa endpoint, but that could be built any way you want, right? And it could be written in any language that you want. I wrote it on Node.js because that's what I know. I don't know Go, but I could have hosted that on Lambda, or I could have just been like, I want to be really cool and write it in Elixir and just host it on an Nginx on my laptop and have it not be scalable at all, right? Again, that's a decision I'm making.
So that was actually a great question from Rogers of Penguins. And I had another funny question for one that said, where do you get the Amazon Game shirt?
I'll let you answer that.
Yeah, let's Game Tech.
Working on a game. Game Tech. I mean, each one, this is my Seattle shirt. But this is the people inside of Amazon. We get different shirts that kind of represent the different places that we're in. And, it's not Twitch, but, because there's some awesomeness there.
Coveted.
I've got to give some love there, but let's get back to the goodies. So, how's PubSub implemented? This is a question from Macaulay Robert, and he said, how is it implemented? Long polling, WebSockets?
Yes, that's done through sockets, through ports, listening to topics, that sort of thing. Long polling you can do for certain things. We've tried to mitigate that through webhooks now, which is, I guess, definitely through webhooks. It kind of mitigates the long polling need, but I guess depending on your use case, there are cases where you could still use long polling. I'd like to hear more about what they're doing, because obviously that's a pain or expensive depending on what you're doing.
So how can they get a hold of you?
You can get a hold of me at my Twitter, which has been displayed, Baxter with 2 R's, 22, or my Twitch. Well, I can't.
Dude, if you could twist all the way around, I'd be impressed.
43 Baxter 4343 is my Twitch. So.
Yeah, and I think the mods on Twitch are sharing our Twitter handles, but we're all there to help. Like this is what we do. We love to help people. Yep. Don't be shy. Reach out.
And understand that's kind of the premise, just so people understand that the things that we're doing with Game Tech is being able to work with everybody between Alexa and Twitch and AWS and all these different services, and it's bringing everything closer to you in the community. It's actually showing you how you can use things in real life, how they actually apply to something that means something, not just creating these aimless demos that nobody cares about or dead-end code. So the more we hear back from you, the more we can actually create. And you can reach me as well. My handle is Obi-Wando. No, it's not a Star Wars reference. It's an acronym. You can ask me, but I won't tell you today. But you can reach me, and a lot of the different comments and things that you'd like to see, absolutely, hit us up. We're looking forward to working more and more with the community and actually going after these things that are totally, out of the norm. So I guess one of the things we probably do is let's go ahead and get back and finish up the rest of our extension here. So let's go back up on the code desk here. And let's one of the things
I've through the rest of how the last moving parts, because we haven't covered the last moving parts about joining a raffle, picking a winner. So let me just quickly show what that code looks like.
Yeah, let's burn through that.
Yep.
And then you're going to tell me how JWT works, with the different roles.
Sure.
Yeah, go ahead.
So that's actually, there's a good hook to that I'll mention the code. So real quickly, just getting through this from a front-end perspective, if you're going to join a raffle, it's going to delegate to a particular API call to say, enter me in. Picking a winner is going to do something similar, and finishing a raffle will do something similar. If we just quickly look at what those HTTP calls look like, you'll see that joining a raffle is just doing a post to a particular URL at the server side. And there's no information about that user here, right? We're just saying, this is the raffle I want to enter. And similarly for picking a winner. So how do we know who should be allowed to do this stuff? And that's where looking at the JWT on the server side comes in. So when somebody says, I want to enter a raffle, for example, the enter raffle handler gets fired, and we look up their Twitch user ID from the JWT. And so that's what we know we can trust, because it came from Twitch.
Yep.
And we store that inside the raffle's participants array. That's basically what this function does. And then we repersist our raffle to our state store. And then when we want to pick a winner, we're doing something similar, where we're just we're calling pick a winner, assuming we have some entrants, and then we go ahead and broadcast the winners back. Now, something interesting to note here, though, is the winners are going to be user IDs. These are not usernames. These are user IDs. And that's not going to be a super meaningful value to display to users.
Right.
But all we get from the JWT is a user ID, because that's a good starting point. And there's a whole concept of user IDs versus opaque user IDs.
Right.
Maybe you want to talk about that for a minute.
Yeah, absolutely. So one of the things that by default, the JWT that is signed and provided an unauthorized callback, at first that will have a opaque user ID. That's a stable reference for the user, but it is not their Twitch user ID. So basically, your extension can request the identity of the viewer, and if that viewer grants the identity, basically that token gets upgraded to have their real Twitch user ID.
Right.
The idea being that you as a viewer have the option to choose whether or not you allow the extension to know who you are.
Right, and for the purposes of a raffle, where obviously you're going to want to know if you won or not, there would really be no way to know that your opaque user ID was you. And so the two ways around this is have the raffle request permissions to get the real user ID for a user, or we could have asked the participants to type some unique identifier in, and then we would store that. And then you would just have to hope that there weren't any collisions between participants writing their names down with the same name.
It's totally okay, though, to hide specific interactions to require identity grants. So basically, you can only enter this raffle if you grant identity. So that's totally acceptable.
Yeah. So just before we go on, one thing we can do if we want to do some live coding here is we could update the code to look up a username for the winner instead of just showing the user ID. So just depending on how time's going, we've got that if we want to do it. Just running through the last of the backend here, so you can see what those things look like when the backend gets so entering. Again, it's just storing it, selecting a winner, storing it, and then deleting a raffle is just going ahead and calling delete, which clears out the thing in the store.
So for these broadcaster-specific calls,
yes,
are you looking for the role?
No. So that's
okay.
I wanted exactly. So I wanted to call that out again for the purposes of just getting something working. I didn't add in sane authentication checks here, but this is exactly where, just like I was looking to see what the role was. Well, actually, I haven't shown that yet. And so to your point about how do I know if they're a broadcaster or a viewer, the last bit we didn't cover was current status. So when the extension first starts up, it makes a call saying, what's the current state of the raffle? So that if you're joining a channel that already has a raffle going on, it'll show the appropriate UI for a viewer to enter as well. This is going to also check to figure out what your role is to let you know in the response that this API generates whether or not you're a broadcaster. And so again, this is just from, you're not going to trust the front end to only make requests legitimately, to your point, right? We should also verify that on the back end. And we would do it the same way we do it right
to keep
here.
calling these things out.
No, it's 100% like great. And then I wanted to have some good
Yeah.
conversations about
Awesome.
this code here. So if you wanted to check the role of your request to see is the person making the request a broadcaster or not, it comes in off of this role field in the JWT. And
Yeah.
just showing the JSON schema.
Yeah, so we do have the full JWT schema documented in extensions under reference.
Yeah, I was just gonna
and
pull that up.
there's a lot of contextual information you can use depending on what you want to do for authentication or for the logic of your EBS. And so you're going to have the channel ID that they're actually coming from. You're going to have, like I mentioned before, the opaque user ID if they haven't granted your extension their identity, or that will be upgraded to the proper user ID.
Yep.
Another thing opaque user ID will tell you is if they are authenticated or not.
Yes.
So you can have an interaction with the user and the extension even if they've not logged into Twitch. But if they log in, that opaque identifier is stable from channel to channel.
Yeah, that'll be if they're prefixed with an A or a U, right?
Exactly.
And for the raffle, and this is me just asking a question, I don't know, is if we have that opaque ID and we have if it's the user's authenticated, we could say, oh, this user isn't authenticated, we're not going to even allow you to
Right.
Yeah,
So
exactly.
you could draw the
right?
line either you have to be authenticated or you have to have granted identity before you can enter. a
Yeah,
raffle.
and from the Alexa standpoint, right, like it doesn't mean a lot to say, oh, the winner is 1225553, right?
Yeah.
So we might want to threshold that out and say we need your user ID to enable this for whatever reason, right?
Yep.
So,
Cool.
talking about the user ID, can we spend like 20 seconds just taking a look at the lookup for user ID?
Yeah, exactly. So if we wanted to change the backend code so that instead of publishing out the user IDs, it published out the username. I was just looking at this
Yeah.
earlier today to see how to do it.
There
There is.
the bottom is new Twitch API.
Yeah, there we go. Thank you.
And then under reference on the left there should be like a get user endpoint.
Yeah, that's what I noticed. Get users.
Yeah, that's it too. It's just called get users, but you can do it to get one user. But you can actually,
There you go.
Yeah,
So I can
exactly.
fetch multiple user IDs at once.
Yeah.
So what's actually nice about this is I can still store the user IDs in my raffle as the entrance, and then when it comes time to pick winners, I could just translate all the winners
Exactly.
in one call if I wanted to.
yeah. And you can actually, depending on the design of your extension, you can call Helix is what we call the new Twitch API.
Nice, so I
you
can see
can
it
call
here.
Helix from your back end, or you can call Helix from your front end.
Right. So if we wanted to have the front end submit their username when they enter the raffle, we could do it that way.
Yep.
Or the back end could be responsible for looking it up. And the cool thing about this is this URL doesn't look like it even requires any authentication, right? I can optionally provide one to get the user's email address.
Exactly, it's optional.
But without anything, I wouldn't even have to sign this particular call from the back end.
Right.
I had a question from Lord Monta, which is that how do I resolve the Twitch username from the user ID?
Yeah,
This is
definitely
exactly it.
this
That's it?
endpoint. Yep.
All right.
Yeah.
Right there. So you
Already
can
there.
use that same endpoint to get ID from username or username from ID.
Okay, cool. So, and then one other question, which library are you using for promise-based HTTP requests?
Oh, that's a good question. So on the front end, I'm not using a library. I'm just using the fetch API, which is just part of the modern JavaScript support in browsers. And then on the server side, we're using the requests module from NPM, which is not promise-based, but you can get one that is promise-based. It's like requests promised or something.
Awesome.
And just to keep it really interesting, I'm doing it a completely different way on the back end for the Lambda function. I'm using async await, but we got a helper function there that I can step through later and just talk to that.
And all of this code is async await too, because if you're writing modern JavaScript, in my opinion, I have a few strong opinions. This is one of them. You should definitely be using async await. The nice thing about using Node.js 8 on Lambda is async await support is built in, so you can use those keywords directly in your Lambda functions. You don't need to do any transpiling to make it available.
Yeah, and if you ever had to think through the asynchronous nature of Node.js, you know how dependent this is going to be, and especially when you're orchestrating multiple things, right?
Yep.
Yeah.
Okay, so in general, we've covered how to look up usernames if we wanted to show them. Depending on time, we can make those code changes or not, but
I think
hand it back over to you.
we'll probably save that back towards the end. But at this point, we've got ourselves a functional, working Twitch extension that does everything we want it to do.
Locally on my
That's
machine.
Locally, but we've got it. It's put together. It works. And so, at this point, for those of you just now joining us, we're doing live coding with an Alexa-enabled Twitch extension. I've got the different dev teams from Twitch, Alexa, and AWS, and we're walking through how to put all this stuff together. We've walked down everything it takes to put together this Twitch extension from the ground up. So if you haven't actually built one, you'll be able to utilize it. We'll have this, of course, up on YouTube and some other pieces, and we'll be building more out of it. But this really gives you everything from how to do it and also what you need to do it and some of the concepts and gotchas and tips and things like that. So we want to make sure that everybody has all the pieces. But at this point, it's pushing buttons, and we really need to invite Alexa to the game.
Yes.
So we're going to shift gears for a second, and we're going to walk over to the couch here, and we're going to talk about Alexa for a little bit. So,
We need Keyboard Cat.
huh?
Just have
Keyboard
Keyboard
Cat.
Cat play to
Keyboard
the couch. Yeah.
Play
just
Royal
saying.
out.
Yeah, right. So I've got Memo here, who's actually from the Alexa Skills team, and he is our local genius that knows everything up, down, left, and right.
I don't know about that, but
Alexa, but I can tell you they love your shirt, dude. There was actually a comment that went in here, and they were like, "This guy's got style." I'm just letting you know now.
as long as my
So-
shoes are on stream, that's the only thing I care about. Broke out new sneakers for y'all.
So, so with Alexa, tell me a little bit about how it works, just like from the underside. Like it's like voodoo. I speak to it, and magically it happens. Like,
Yeah.
What's all that about?
Yeah, there's two approach ways of thinking of it. One is like it's just magic, and then people that have worked in language and grammar is like, oh man, you need a PhD to build one of these, and it's somewhere in the middle where we have a device right here, right? And when you talk to it, it's all audio, it's all sounds. And when you say something, what happens is that audio gets streamed up to the cloud, to the Alexa voice service, which is a service that's coincidentally built on AWS. And that service turns your speech by using automatic speech recognition, or ASR, into text. And then we use that text and pass it into a natural language understanding engine. And we take the meaning of that speech that you just uttered and turn it into a JSON object. And then we send that JSON object to an endpoint that the developer registered with us. So basically, from a development standpoint, you give us some data so we can map a user input to a JSON object, and then you tell us where you want that JSON object to go. And computationally, all you're doing is you grab that JSON object, you unpack it, you're like, oh, I got this flag, I'm going to send this back. And all you're sending back is strings or references to files in case you want to play a sound or include images or displays for devices with a screen. And the service turns that into an actual speech for the user. And the model that it works really, really nicely with Lambda because it's event-driven. Every one of those JSON objects is a new event, and then Lambda can just react to each one of those, which goes back to Gabe's point, which was it's very good for scaling. It allows me to grow, and in Alexa we have a phenomenon that's similar to what Travis was describing with Twitch, which is if something gets popular, it gets real popular real quick, right? Well, we've got stories of developers build something, release a new feature, go to bed in their own time zone, and then they wake up the next morning and they're like, oh my God, 100x growth overnight. And as long as they architected it properly, they're all fine, right? And
if not, you get a lot of calls.
yeah, and I like to tell devs that
Kind of like why we're here, right?
the quickest path to a 1-star review is building something people like and then breaking it, right? Like
Yeah.
Even, right?
Yeah.
Yeah. It's
yeah.
so. There's different parts in Alexa's skill kit, and we keep hearing this terminology like, it's a skill, invocation, intent, utterance. Cool, it's voodoo. What is it?
So we just like our own terminology for whatever reason, but the first place to start is what's a skill? And a skill is a voice app. It's just something new you're going to teach Alexa. You're going to build something as a third-party developer, and you're going to teach Alexa how to do something new. It could be calling an API. It could be whatever you want, really. And you're building a voice user interface.
So that's really the skill is the program. You
Yes.
know, like in traditional programming, I build an app, I build a program. A skill is the program.
Yes, and then like any program, it's got two parts. It's got a front end, it's got a back end. Typically, when we think of the front end, it's graphical. It requires a screen, it's got buttons, you click on it, there's something you can look at, read. In our case, it's all voice. So it's all driven by what the user is saying and what the user is hearing. So there's no graphical component most of the time. Some devices might do what we call multimodality, so they're both voice and something you'll see. But voice should always be the best experience, the first thing you think about. And it's surprisingly hard to think about that because for most developers, or most of us, we come from everything has a screen. Like you just don't think about devices without a screen. So it's a little bit, it takes a little while to get used to. Instead of thinking, does that word look okay? Reading it out loud and saying like, how does that sound? So even those little changes take a little while to get used to.
I'll admit I did cheat a little when I started building my first Alexa skill. I bought a show as my debugging interface.
Yeah. So
It didn't do anything else other than just debug for me, but that's, you know.
and not everybody can do that, but it's a good place to start. We also have simulators on the developer.amazon.com, which is the web portal for building this. Once you have that voice UI, and we're going to go through all of this, and we'll actually build one live on stream. The second piece you have to build is your backend, or we might also call that an endpoint. And it very much works like a web app, where you're just sending objects and getting responses back. The easiest, most frictionless way of doing this is with AWS Lambda, because we don't have to do what Gabe did, which is fiddle around with SSL certificates and do everything through HTTPS and get a domain name and et cetera, because we know we have a certain level of security with AWS Lambda, and then we can do some extra magical things between the two services by sharing the ID for the Lambda function and the skill, and making sure no one else can invoke our skill. Because it's the internet, people are malicious, even if it's just for fun, right?
Yeah, so, you know, the different parts of it when we're talking about it, what are the pieces that kind of make up that command when you're using that interface? People are used to a button, a click, I see, but what are the pieces that actually make up my interface when I'm working with an audio-only device?
And a lot of people are familiar with how the device gets invoked. So just fair warning, I'm going to invoke everyone's device at home right now.
So put your Alexa close to the feed, right?
Or mute it, alternatively.
Do your best Eric Cartman voice when you say this.
So the way ours is going to work is you're going to say, Alexa, start the Twitch raffle. And that sentence has several parts. One is Alexa, which is going to turn on the device. It's like pushing a button to just wake it up.
What is that?
We call it the wake word.
Okay.
Right? And there's 4 wake words that your device can be set to: Alexa, Echo, Computer, or Amazon.
Which is good because my wife's name is Alex, so.
Yeah, exactly. So if you have someone that's name is Alex, Alexa, Alexandria, Alessandra at home, you probably don't want to have that as a wake word for your device because you're just going to be triggering it all the time. I have most of my devices are set to computer at home because I don't say the word computer that much. But in the office, you'd be surprised at how often that just comes.
Kind of a Star Trek thing?
Well, even if they just say, like, is that your computer? Yeah. So it's one of those 4. It's a wake word. The device just sitting on the desk is not really doing anything.
Right.
And there's a lot of people that are privacy-minded. They want to know about that. There's 2 ways you can test that out really easily. One is hook up your device, set it all up on a Wi-Fi network, and then with a router or a switch or an access point, and then remove the connection to the internet from that device, from that switch. And then if you try to talk to the device, it just won't be able to do anything, right? That's one way to just say, like, where's the communication stopping? If you want to go one step above, get Wireshark or a network sniffing tool, and then you can just look at the device and say what's happening at any point, and it's literally not transmitting anything until you say the wake word. Once you say the wake word, it's going to go nuts because it's going to start streaming audio immediately. It doesn't wait for you to finish a sentence to upload that whole thing. It just streams it in as it's coming through because that's how we process speech even as humans,
It's
right?
kind of like VoIP. I mean, it's literally just taking it and it's VoIPing it up to a server.
Yes, it's a good analogy, right? And it's also how we understand sentences. You don't wait for me to speak for a minute and then you think about, and then you engage with it, right? Like every word, it gets processed almost independently.
That makes sense. Now, there is a question that came in from Alistair Plays, which is, Are there any plans for custom wake words?
It's something that we've heard from a lot of people. It's actually there's a limitation there on the hardware, right? The device is amazing. It sounds really well. It's got an incredible microphone array. But if we built capability onto it to just listen to any word, we'd have to put a bigger processor on there or do a lot of re-engineering. So right now it's not something that you can just do out of the box.
Because you're actually processing the wake word locally.
Correct.
Whereas everything else is VoIPed up.
And that's a great point, because we're used to, as developers, where you code something, it's running on a machine that you that you understand. If you're making something for a phone, it's mostly running on the phone. If you're making an extension, it's running. You're seeing that render on your browser, on your computer. With Alexa, everything is getting processed in the cloud, and then you're just getting the response back on the device. Very little processing is happening on the device. It's incredible at signal processing. Like, it captures audio really crisply, it sends it, it encodes it. But all the logic, all the language is all happening in the cloud with AWS.
So we've had that sentence. We talked about wake word. I mean, what are the other pieces of that?
So once we've woken up the device,
which is what, Alexa, start
Echo,
Twitch raffle?
Right. Yeah, exactly.
Alexa. By the way, after the couch session, I'm sure we'll come and we'll show how this is all configured on screen.
Yes,
we're
going to.
So if you're watching and you're wondering what does this look like, what Memo's talking about, you'll see in a minute.
Yeah. We'll do the whole thing. What's it? Soup to nuts.
Soup to nuts.
Top to bottom, soup to nuts, all kinds of fun ones.
We'll do it all on stream. And what we're going to do is we're going to give it an invocation name. In our case, it's called Twitch Raffle.
Okay.
But just saying Alexa Twitch Raffle is like speaking like Tarzan. And we want our users to speak properly, conversationally, like real humans. So saying Alexa open the Twitch Raffle, Alexa launch the Twitch Raffle, Alexa start the Twitch Raffle. All of those are valid. And there's more verbs that you could use, and we call those launch phrases. And there's about 12 of them in English. They obviously vary per language. And we're super happy that Alexa's become this global thing, because now we don't only support English, although we have English for multiple countries like India and Canada and Australia and New Zealand. We also now have support for French, for France. We've announced that we're coming to Spain. We're going to Italy. So this is super, super exciting, a really good time, but it requires some different thinking. So each of those sentences would be built out in a different language. So in Spanish, you might say, Alexa empieza el sorteo de Twitch, right? And that's the exact same sentence, but I'm going to have to train it. So in one of the invocation names, it's going to be Twitch Raffle, and the other one is going to be sorteo de Twitch. It's the same thing, but I want it to be in the right language.
I'm glad you said it, because I could not.
Well, one of the benefits of growing up in Mexico is you learn Spanish.
So I guess so what we're saying is that you've got the wake word, you have the invocation of it, and from that there was other things we were talking about, like intents and utterances.
So the next thing that the user would say is an utterance, like pick a winner. And that is just the meaning of what the user wants to say. We're going to group it up and send it as a flag. So there's many, many ways of saying pick a winner. Pick me a winner, I want a winner, give me the winner, give me the winners. All of those kind of map to the same thing. So
it's the intent of what you're trying to say, not specifically what you're saying.
Yeah, it's not the actual sentence that you're saying. It's going to get boiled down to the intention, to the meaning, and we call those intents. And as part of that JSON object that we were talking about earlier, it's just a flag in there. And we could call it get winner intent, or pick winner intent, or winner intent. It's just a flag. That actual sentence doesn't mean anything, but we're going to give it a set of training data that we're going to feed into the natural language understanding engine, which sounds all very fancy and very hard, but it's actually very straightforward and pretty easy to build.
So when we talk about this, we have Alexa, which is our wake up, Twitch Raffle, which is that's our invocation, and then start the raffle, right?
Yep.
And that's our utterance.
Correct.
And so the reason why we're going through all these things is that you're going to see a lot of these go into the interfaces, and you're going to have to understand that when we're breaking these pieces out, these are the core fundamentals. You basically have the piece that will wake the device up. Then you've got the actual name of the application that you're trying to start off, in this case, the Alexa skill, which is the Twitch Raffle. And then on top of it, your utterance is like the variable that you're trying to pass in for that part of it. So things that you're used to where you find a field, and you plug a number into it, and you click a button. In this case, it's really the scenario where we've got all that built in, but you're actually saying it, and the way they're broken out is how you'll address it in the interface. So I guess with that in mind, if you want, let's go ahead and get the developer.amazon.com up on full screen, and let's get into it.
Yeah, and I'll walk through with Gabe on how we're going to build this out on developer.amazon.com.
And so, while we're kind of getting set up, can we, why is that the first place to go?
So what we're going to do here first is build the voice UI, and I think we're going to switch over to my laptop.
After you log in.
Yeah.
We'll go to secondary after Memo logs into his computer.
So
We'll give him a minute.
lot of moving parts here. One quick second. What we're going to be doing is we're going to be building everything from developer.amazon.com. And right now we're looking at Gabe's.
Let's make sure we're looking at Memos. Let's go to the secondary full screen now. Okay.
Your taskbar clear?
I'm all good.
Okay.
It's always those small details, like leaving your password on a Post-it note.
Yeah, I tried doing that earlier, but you didn't like it.
Let's go ahead and switch over to the secondary machine.
Yep.
If that doesn't work, we just...
No, we're good. We're good. It's streaming.
Good. All right.
Okay, cool. Sorry, our confidence monitor is showing a different thing,
Yep.
and we're getting
wasn't
thrown
confident.
for a loop.
It's okay. I saw the thumbs up in the booth.
Sharp eyes. That's a password manager.
So what we're going to do is we're actually going to show the second half of this equation. We've walked
Yeah.
through and we've shown everybody how we did it on the Twitch side. Now we're going to get Alexa to actually invoke our action so that it's pushing the buttons and doing the piece for you. And that's the whole point of why we're doing this in the first place, is so that the actual people who are running their broadcast, they don't have to switch off and switch out of the game. They want to be able to use this new interface, which is an audio interface, to actually do all the controlling actions. And so that's where we're at now, just for you that are kind of tuning in. We've done the Twitch side of it, and now we're moving over towards the Alexa side, where we can understand, instead of using a visible interface, we're using an audible interface to actually control what the Twitch extension does to allow you to engage further with your community and not have to leave your stream.
So what I'm doing is I just logged into developer.amazon.com, and we have an account that we've been sharing to work on this. And I'm just going to go back to the main page. And all I did here is click on Developer Console. That takes me to the different pieces that are here. So if you were building an app or doing different things, in our case, we just want Alexa Skills Kit. We're going to click on that. And here I have a single skill that I already started. It started as a proof of concept for something different, so it's called Twitch account linking. This name is just
internal developer reference.
Exactly. For now, it doesn't really matter what the name is. The name that matters a lot is the invocation name.
Yeah.
And this, again, is all going to get built through here. If I click on invocation now, I see I got Twitch raffle here. It's really important to think about this in the context of what the user says.
Yeah.
So if you have a typo there, it goes from raffle to raffly, right? Or Twitch to twitch, right? Like if you have a typo here, it's a big deal.
And what about words that sound the same but need to be pronounced differently?
Yeah, so for a while there, the cool thing was to drop all the E's from like the name. So
Sure.
it was like, if it ended in ER, you just drop the E and it was an R.
Like
So
Doppler or something
Yeah.
with the R.
yeah,
Doppler.
so if you did Doppler without an R, it'd be like Doppler, which is hard to say.
Yeah.
And people wouldn't actually say that. It'd be hard to trigger. So you want to keep this really to the point, easy to say. Don't make it a tongue twister. And
Right.
there's certain things that look and you can read them perfectly fine and in your head sound fine. But if you try to say them out loud, it's hard. And one that stuck with me, and this is like 2 years ago, I was at the University of Washington teaching people how to build skills, and someone tried to make something called false facts.
False fact.
And it's very hard to say.
Yes.
I've said that 100,000 times now, and I kind of can say it, but the accuracy for capturing that invocation name was really low. And this college kid was like, oh, this doesn't work, it sucks. And I was like, let's just change it to something else and see if it's like a automatic speech recognition problem.
Like pretend facts.
Yeah, or banana table.
Banana table.
And we did that. It
what I
started
would've
working immediately.
My new password.
Yeah, and I was like, okay, it's because it's hard to say. So then we changed it back, and we were like really enunciating and speaking clearly, and we got it to trigger. But I was like, your user's not going to do that. No one's going to really hang around to do that.
So that's a good tip.
Yeah. So what we're going to do here is we're going to add some intents. I have a sample intent here that's called ID intent, and this used to give me back my ID number for Twitch, and we're going to knock this out, and we're going to build a brand new one. But I just wanted to show one, which I have training data here. ID, tell me my ID, please. Please give me my ID. What is my Twitch ID? What is my ID? All of those, sound very similar, but they're structured a little bit differently. Please is moved around in the sentence. And this is just like bare minimum. You want to have quite a few of those, and you really want to give it a good think how are different users going to say different things. So we have an intent, we have an invocation name. Typically what we would do here is click build model. That's going to take all this data, pass it to the natural language understanding engine, and it's going to take about 1 minute to build that out into an actual grammar that we can use.
I'm always clicking save before I click build. And do I have to be careful about when I do that? Like if I changed it from Twitch raffle to banana table just then and clicked build without clicking save, would it save and build?
It would save and build,
Okay,
but,
cool. Just saving me a
clicking save and then clicking build is something I do all the time because I just want to be extra sure.
Me too.
So in general, if you click build, it's just saving it. But
Good to know.
Also, this portal, it's sometimes temperamental, so that save button is your friend in case it times you out or something. You don't want to lose all that hard work you put into this.
Cool.
So now that we have this little UI built out, we're going to hook it up to a Lambda function. And we also built that Lambda function already. We have a very minimal one that we're going to be editing and adding to as we work through this. So I'm just jumping back. I'm going to the developer console for an account that we have, and we have a Lambda function that's called Alexa Skill Endpoint. And I just wanted to show a couple of things that are important here.
Yep.
One, we have this trigger, and this is defining what type of event can actually make this Lambda execute.
Yeah.
In our case, it's Alexa Skills Kit. You can find all these triggers on the left-hand side of the Lambda function. The Alexa Skills Kit trigger is only available in certain regions. So it's available in Oregon, it's available in North Virginia, it's available in Ireland, and I'm blanking out on
You got quite a bit of coverage that's actually in a lot of different places.
Different geographies, yeah.
And so, given that, very cool.
Yeah, and as a service goes more global, we want to have those endpoints be closer to the users, so there's no latency problems. Because the last thing you want to do with voice is have pauses in there. If you want to kill a conversation, the first thing you don't want to do is like take a large pause in there.
Cool. Okay. So we've got it set up now so that we know what is going to trigger this Lambda.
Yep.
And now you want to go ahead and talk about what's going to happen afterwards?
Yeah, so this represents our code, right? And it's going to be at the bottom of the page. I'm not going to check it out right now because I want to get kind of done with the designer for a second.
Yep.
On the right-hand side, what we're seeing represented is all the services that this Lambda has access to. And we talked about IAM earlier, right?
Yep.
Which is Identity Access Management. Through IAM, we created a role to assign to this Lambda function to give it access to something.
Right.
We got lazy and we just gave it like a role that has all the permissions in the world.
I think it's an okay thing to do during development time, but when it comes time to put this thing prime time production mode, you always want to follow the principle of least privilege for what you're granting.
Correct. So if you hire a new developer at your company, you probably don't want to give them the keys to the castle and be like, here's the database with all our users stored and all our credit cards and all our content, and then go to lunch and then come back and he's like, I was running some tests and I kind of dropped that table and it's not backed up anywhere. We don't have users anymore. So it's the same kind of deal.
Similarly, you don't want to do that for any of your Lambda functions because then that somebody might think, oh, I'm just dropping the tables for whatever this Lambda function could do, and oh no, it had full access. So always lock it down.
I had a moment of panic like that the other day where I was doing something on my developer console. I clicked edit and I was going to delete a function. And the UI, after I hit delete, didn't refresh quickly enough. And I was like, did I just delete every Lambda function I have? And like my heart stopped for a second because I didn't even know what was there. But it was just like a UI glitch.
Luckily, I'm pretty sure it won't let you can't. I don't think you can mass delete functions from the UI, so that's good.
But it just like my heart dropped. It was not a good feeling. And then what I did is I just collapsed this designer.
Yeah, so we can focus more on the code.
Correct. And so in order to look at my code, I'm just clicking on this box right here, and you can see that little arrow animation pointing you down to that.
Now, if you've never worked with Lambda before, it's a good thing to mention that you have an interface where you can edit directly from the web console, but you can also package things up and deploy using an API. In the case, like for what I was doing before with the SAM local, there was a command for packaging and deploying with CloudFormation. So there's a number of ways to work with Lambdas. We also have Cloud9, which is our
Yep.
editor in the cloud that makes it very easy to take a Lambda function that's already deployed and edit it if you needed to make some quick edits for something. So you have a number of options. In this case, we're using the embedded editor right here.
And I'm just using Cloud9 right now. There's a number of options. Another one, if you're just doing Alexa skill development, we have our own CLI, the ASK CLI, that we publish as an NPM package, or NPM module rather, and we can just say ASK deploy and just deploy your Lambda function and do all that fanciness from the terminal, but it's we didn't want to go into tooling necessarily.
Yeah,
We're just
exactly.
and this is a little bit friendlier, right?
Yep.
So I'm just going to go full screen here with my code. I'm probably going to make it a little bit bigger. I was cheating and looking at Twitch chat earlier when you were streaming, and they were complaining that they weren't blind and yours was too big. I usually get the other complaint, which is, geez, Memo, I can't read anything. So let's straddle the line.
Let's try and find a balance.
And the first thing here is I wanted to call attention to what's on the left-hand side of my screen, which is all my dependencies.
Yep.
So I've uploaded these dependencies as a zip file to this code, and that's why I have access to them. I have these node modules, and one is ASK SDK Core, which is the Alexa Skills Kit software development kit. And I've got the core one because I want to keep my deployment package small, so Cloud9 could let me still edit it.
Yep.
And that has one single dependency, which is this ASK SDK model. So I have those there. It's important to understand that. We have a bunch of tutorials if you go to github.com/Alexa, and you can learn how to do this all in detail there. But if we did every step in detail, we'd take forever.
Let's also just quickly mention one of the dependencies not there is the AWS JavaScript SDK.
Correct.
And that's because it's included for you automatically in the Node runtime environment from Lambda. And I was just talking with a developer the other day who didn't know that.
And he was uploading it
He was
every time?
uploading it every time, and he was like, my Lambdas, the sizes are so big. And I said, you don't need to include that.
Yes.
And so if you didn't know, you don't need to include it.
Yeah, and Lambda has a few of those packages already included, and another one is this HTTPS package.
There you
go. So it's not included here because Lambda already has it. I'm not re-uploading it.
Right.
It's there for me. Then I've got my code here in this index.js file, and then just package.json, which are just npm for dependencies. So I'm going to hide this thing now just to have a little bit more real estate. And what we have here is a very, very basic Lambda function that'll handle requests coming in from the Alexa Skills Kit.
Multiple intents.
Yes, multiple intents. So right now we have a launch request handler. And the way we define our handlers, which are the pieces of code that are going to react to a specific event, is we give it a name, and then they have two parts, can handle and handle. And the can handle, all it's doing is it's going to waterfall through all my can handles until it finds one that returns true. Once it finds one that returns true, it'll run the code in handle. So in this case, when we get a launch request handler, it's going to say, this is a Twitch raffle extension. Please say start raffle, pick a winner, or end raffle.
Right.
I want to test that out right now just to see that it's hooked up to our device.
Yep.
And then Braxton did me the favor of unmuting our device because otherwise I would have triggered it 100 times. So it's Alexa, open Twitch raffle.
This is the Twitch raffle extension. Please say start raffle, pick a winner, or end raffle.
So hopefully that came through on the stream audio.
Yeah, so they've got
Amazon
they've got it
fallback
mic'd up.
intent has not been implemented.
That was our fault. So what it said there is like the Amazon fallback intent's not been implemented, and the reason it said that is because I have this unhandled intent handler, and it returns true for everything. So if I get an intent that I don't have an actual handler for, I just have it read the name of the intent from the object and just say it's not implemented. It's kind of my own debugging.
Yep, it's very helpful.
Kind of like, Memo, you're doing something silly. Something that's really important to understand is here at the bottom is how are these different handlers getting registered with the SDK.
Yeah, exactly.
And what we're doing here is we have this method called add request handler. I'm also adding an error handler in case I get a syntax error or whatever. I want to hear it when I trigger my device. And finally, I have this little helper function. For people that were asking, I think there was someone asking it specifically about using HTTPS and promises. I made this I took like multiple temples out of the internet and just mushed them all together so I got something that uses promises async await and does HTTPS without having to import a third node package.
Right.
Because I like.
And it's not that many lines of code, to be honest. So.
No, and I'm masochistic, so I was like, why do it easy if I can torture myself?
It's fine.
So all it does is it returns a new promise, and then it's wrapped in async. I can do that for free because it's Node.js.8. If you want to take a look at this, we can go line by line maybe later. If not,
This is not the interesting part, though.
Yeah, I've got some comments in there. You should be able to figure it out. And all this code is going to be live after this stream in the GitHub repo that got shared, and it can get shared again in a second. So the real interesting part is we want to start a raffle, right?
Yes.
So I built this handler that's called start raffle intent handler, and what it's going to do is it's going to return true when I get this start raffle intent flag.
Right, which we haven't set up yet, but that's what we're going to use as our intent.
Correct. So we haven't set up that intent. I think we should go out and set up our 3 intents.
Yes.
Start,
pick a winner, and end.
correct.
Yep.
Start, stop, and pick a winner. So I'm going to go back to the developer portal, set all that up, and then we'll keep on going. So I had this kind of sample intent in there.
Yeah.
I don't want to have it in there. I want to get just rid of it for the time being. And I'm going to add a new intent.
Yep.
There's two types of intents built in, which are have this Amazon dot something in there, and those we give you if you just want to grab them. You don't have to provide any training data, anything else like that. By default, if you build a blank new skill, you're going to get 4: cancel, stop, help, and fallback. And fallback is the user said something that doesn't match to anything.
Right.
I'm going to grab that one.
Right.
Cancel, stop are for when the user wants out, right? Like it's almost like in a window, you have those 3 little controls that the user always sees, regardless of what they're playing or what they're doing. And finally, help. We assume users might want help at any point, so we're going to give you that one for free. Don't want you to reinvent the wheel every time. So I'm going to add a new intent. I conveniently copied the string I had in my code, so it matches 1-to-1. There's no typos. I'm known for doing that on stream. And I'm going to create a custom intent. Now that we got that custom intent, what are things that people can say to start a raffle? So one would be, let's
start a raffle.
Start a raffle.
If you have a suggestion on stream as a viewer and you want to write in the chat, maybe we'll add some
let
of
us
those
know.
too.
Royal can
Dude,
call
raffle,
them.
please.
All right.
Dude, where's my raffle?
Dude, where's my raffle?
I can't do commas. Dude, raffle,
Dude, raffle, please.
One raffle, please. I want to start a raffle.
Maybe begin raffle, also different verbs.
Different verb, begin.
Begin a raffle. Yeah.
There's another one which is like, don't end every sentence with the word raffle at the end, because then you're training your model to look for sentences that end in raffle rather than the syntax. So the other one is like, don't make everything singular. If you have an I, have a we. So we want to commence a raffle, right? Another verb for whatever, right? So make sure you hit enter so they're all actually there.
Yep.
So now we're going to hit save because we have a new intent. The next intent we're going to make is a pick a winner, right?
Yep.
Pick, and I'm going to call that pick winner.
Pick winner intent.
Intent.
And you don't need to suffix these with intent, but it's generally something that I see a lot of example code doing. So.
And we do it, it's a little more verbose, but I think it's a lesson I learned when I was in college where I would just call all my variables A, and then it's 4 a.m. and I can't debug anything. So is this the intent? Where's this name coming from? So the first one would be pick a winner, right?
Straight pick a winner.
To the point. And then we could say, who are...
well, it picks one at a time. So
okay. So who
for now, let's just say who is a winner?
Who is the winner? You said a different one, which is quite similar, but...
Who is the winner?
Who is a winner?
Who is a winner, right.
Yeah.
Yep.
We could just have the word winner there. Like we just say, Alexa, open the Twitch raffle winner.
Winner, winner, chicken dinner.
And nice, I like that one. Winner, whoa, winner, chicken dinner. All right. So.
Remember to hit enter?
Yep.
Okay.
So now we're going to save that model. We've got minimal training data. You would spend a lot more time doing this. If you're building an app or a website, think about all the time you spend on your UI. You want to spend that same amount of time in this UI.
Yes.
It's not something to be skimped on. And as Royal was saying, you want to think about that whole sentence. Alexa, ... right? So Alexa, open the Twitch raffle and chicken winner.
Yeah.
Winner, winner, chicken dinner, right?
winner?
Chicken winner. So now that we've got this, we already have a stop intent, which
Yep.
is Amazon.stop intent. I'm not going to make another one, but I did want to show something, which is you can overwrite this or like give it more training data.
Great.
So let's say we wanted a specific word that ends the raffle just because.
Abort.
Yeah, exactly. So we can say abort
Bail.
or bail. Whoop. Oh, come on.
Bail out, bail, whatever.
Yeah. Bail out.
And anyway, you can, and this is not replacing, it's adding
No,
to
it's
it?
adding to
Great.
it.
That's
So
good to
everything
know.
that's already in that built-in intent is going to stay there. We're just adding more training data to it.
Cool.
So now we have our 3 intents. I'm going to hit save model.
Is there really something that's like too much training data? Like, is there like a happy medium in here? Like too little or too much?
The concept of overtraining an intent exists, and it really what happens is if you have there's a couple scenarios, but let me just break them down. The first one is you have multiple intents in your skill, and for one you have 100 sentences, and for every other one you have 3 sentences.
Right.
So you're basically signaling to your model everything is going to go here, and really, really specific things are going to land here. So that's overtraining. The other one is if you go way too generic and think about how bot would do a language, and it would just go like verb, noun, adjective, verb, noun.
Like playing interactive fiction.
And
Yeah.
then you expanded those.
Yeah.
And then you just dropped all in there. That intention is going to grab everything. There's going to be no meaning. There's no context. This is language, right? Like we want it to
Yeah.
be actual sentences that people will say. And we're building more and more tools to do this. But if you type one sentence and you had an API that turns that into 1,000 sentences, then you just have a bot training a bot training a bot, right? It doesn't really add value. Like any UI development, it's 50% science, 50% art. So you're going to have to
Yeah.
do tweaking and
Yeah, maybe
different
responding to feedback from your users too.
Yeah, and that's an excellent point. We have a ton of tools now. Like we just released one that'll let you know, show you how your users are moving through intent. So they hit this intent first, then they go to
Like
this
a
one.
funnel.
So you can kind of figure out what's working and what's not. Maybe you just need to clarify because they're trying to get here,
Right.
Yeah.
but it's taking them a handful of ways to do it.
Yeah.
That's actually very sweet feedback.
And the other one is fallback intent. That was a top request from our users. Where like, what if they say something that's completely off the board?
Banana table.
Yeah, banana table.
That's
So-
what I would have thought.
Yeah. So then you have the fallback intent, and you can say, hey, currently we don't support banana table.
Right.
And then just fail gracefully, right? And there's a lot of like little particular things about speech. One is when you're asking questions, making sure that you're asking the right questions. So if I come up to you at a barbecue and I'm like, do you want a Coke or a beer? And
Right.
especially if I pause like that, you can just say yes. And yes is a horrible answer for me because
Yeah.
as a person speaking, I have to do error handling. Yes, what?
Yes,
Coke,
yes,
yes,
beer.
beer. Now we're not even speaking. Those aren't sentences, right? Yes, Coke, yes, beer.
Right.
Doesn't mean anything. Or I can just go off and be like, all right, half Coke, half beer, and give you a glass of horrible something.
Right.
But it's my fault because I asked the wrong question. If I
Right.
said, we got Coke and beer, what do you want?
Right.
You could have said tea, and I'm like, I'm sorry, fallback intent.
We have Coke and beer. Which would you like?
Yes.
Cool.
And then you're staying in my wheelhouse. I don't have to do error handling. I write less code,
That's nice.
which makes me a happy developer, right?
That's a good tip on how to frame your
Yeah.
prompts.
If you ask the right questions, you're going to get the correct answers, and it's going to make your life a lot easier. So,
So coming back here, full screen on the secondary.
yep. So what we have here is the different intent handlers that I've built. And right now we just have one for launch request that is going to give us that greeting and prompt us. And that's why I had it saying start raffle, or say pick winner, or say end raffle. Because I wanted to prompt our users to do this. I also have a note here to myself. This is Gabe's endpoint, so I know what to call. For start raffle, what I did is I'm going to make a call to his API gateway so I can actually trigger that functionality. So the way it's working right now is when I do that, I'm creating this options object, and it's got the host for his API gateway. It's defining what port it is because we're doing it over HTTPS. And then I'm just hitting prod raffle /raffle/ create. And then I'm posting to that. So it's really just an HTTPS code. We're not doing any language magic here. It's just a Lambda function running node making an HTTPS call.
Is there any kind of like special things that you need to do so that you make sure that it has any security implications or anything like that?
So right now we wanted to make it as clean and like as proof of concept-y as we could to make it really readable. So what we did is we implemented a custom header, and it's called skip auth. So what we do is we pass this in skip auth, and if it's got that header, it knows that it's coming from somewhere else. And then Gabe did a little bit of work on the back end for the API gateway, where we are validating it's coming from the right ARN. So we're only tuning there. We're not completely exposing everything. But if we were going to take this to prod, we would be doing JWTs over here. I would do a concept which is account linking. I'd have my user log in with their Twitch account. I'd get their a token or an authentication token for them, and then I could use that and JWTs that I could sign and pass to Gabe to get an identity matched to the extension. So we could secure all that using OAuth and JWT. So we can make it as secure as we want, but all that ended up being like a ton more of code that wasn't really what we wanted to get to, and we're kind of tight for time anyway.
What are some of the nuances, though, that the Lambda endpoint nuances that you kind of have to deal with? Things like, handlers speak, reprompt, things like, are we too far ahead right now?
No, this is the perfect moment. So the last piece of this is I have a function that's called build Alexa response. The only reason I'm wrapping this in a function and not just doing it inline is because I want it to be asynchronous. So here's where I'm actually making that HTTPS call, and by making it asynchronous, I know this is going to happen how I wanted it to. So if we can go full screen on the secondary laptop, what we have here is I'm saying let response from extension is just a variable, and it's awaiting this HTTP request promise that I created, passing this options object. So I'm just making that call here, but I'm waiting for the response to come back before I do anything else. Because if I don't have this response, it doesn't mean anything. I haven't done really anything. And the next thing I have is actually related to the Alexa skills kit specifically, which is I'm returning an object, which is a handler input dot response builder object. And here I'm saying dot speak, which is what the device will actually say out loud. And then by doing get response, I'm signaling to the SDK, package this that I just told you into an object. I return that to this function, and then I have the whole handler return that, right? So we're just passing that object back. Right now, if you noticed, I just have dot speak.
Yep.
Oh, okay.
So you could also have ones to show you on.
Yeah, I could pass back display template if for a device with a screen. I can also have a reprompt like you mentioned, Royal, which is I say, what do you want to say? Start blah, 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 blah. And the user doesn't say anything. They just sit there. They're kind of stunned in a sense, right? After 8 seconds, I can go, hey, I'm still waiting to hear what you want to do. Right?
And you can customize what it
reprompt.
says there with the reprompt, which is nice, right?
Yeah. So I can just go dot reprompt
Right.
and include a string in here. Whoop, that's not a string. And just say, still
waiting
to hear what you want to do.
We have a typo on what?
That's all right.
Wahat.
So-
I'm interested to hear what she says, actually.
And to kind of bring everybody up to speed here, we're actually spending a moment here to walk through how to build a Twitch extension that is Alexa enabled. So the idea here is that we're walking you through all the pieces. We've already done the Twitch side of it, and now we're walking through the Alexa parts of it. And so on the Twitch side, it was built kind of where you have buttons to do each one of the parts for both the broadcaster and the viewer. And we're tying in the Alexa side so that it's actually pressing the button. So we're replacing that user interface from the Twitch side with an audible interface from Alexa. And this allows the people who are actually streaming their games to further communicate and to work with their different community of people that they're streaming to without having to get out of the game or interrupt the stream or kind of break that mojo that they're really into.
Yeah.
So that's where we're at now. And Memo here is walking through the rest of it, and Gabe here. He's been our great test guinea pig of actually putting all this stuff together. Yep. So we have people from Alexa, Twitch, AWS and Game Tech. So
Yeah, no, that's a perfect summary of what we've been doing. So what I'm going to do right now is I'm going to generate an object that then I can use to debug this Lambda function to just test it out, right? Before we go all the way to the device. So I can do that by going to developer.amazon.com again. So there's a little bit of switching back and forth between AWS console and developer.amazon.com. And here I'm going to hit this test button. And what's happening here is this is going to open.
What's cool about this too is if you don't need an Alexa to build an Alexa skill, which is something like that's a good thing to call out specifically.
Yes.
You can do it all right here in the developer console.
Yeah, so depending on how we feel about things, it's also a good thing. You don't even need an IDE, right? You can do everything from a browser. I've built Alexa skills on an iPad.
Yeah,
and
cool.
just like everything from the browser, no IDE, no nothing.
Nice.
Because I got Cloud9 from AWS, I've got all of those different things. So it's any tablet, any web connected device would allow you to do this. Obviously, you're going to start hitting some limitations eventually.
One of the coolest things that I loved about using that interface when I started building one was the fact that when I put it in and I tested it, I could actually see what was coming in and out.
Yeah.
And being able to build my test cases by copying and pasting what I was going to do for that invocation and for that particular utterance, because I would have all my pieces put together, and I want to debug this thing, and so I copy it right out, since I don't have to figure out how to build it. It's all done for me, paste it, and then call that code, and I can test it over and over and over.
We can even show that here.
Yeah, I think we're going to do that right now. And one of the things that no one wants to be doing is editing JSON by hand, right?
Yeah.
Like that is not something you want to be spending your time doing. So what I did is I typed in start Twitch raffle. I could have also used a microphone on my laptop, but I don't know how everything's rigged up, so I don't want to do that. But what happens is on the left-hand side, I'm seeing the conversation, start Twitch raffle, and then the response. This is the Twitch raffle extension. Please say start raffle, blah, blah, which is the sentence I had typed in there.
So that came because behind the scenes, the Alexa developer portal actually invoked the Lambda and got the response.
And this is all built exactly like you would build an actual hardware device. It just happens to be web-based, right? And here, on the left-hand side, this is the object that gets generated off of this little sentence. And this is the object that gets generated from my Lambda function.
Right.
So I'm going to take this object on the left.
And this is exactly what Royal was talking about. We can copy this and use this in the Cloud9 editor to continue testing without having to use this interface if we wanted to.
Yeah, so I'm just going to do that to make it a little bit quicker. But you can also do it if you're pulling down this Lambda function, have it locally, and you want to test and like step through functions, which was something you and I were talking about earlier. Earlier. So that's like yesterday.
One of those
and
times
earlier.
in the past. No, we get.
So I'm going to click on this test.
Configure events.
Yeah, on the drop down, configure events. And here, I'm going to create a new test event. I'm going to call this launch.
We already had one called Start
Request.
Raffle, but it's basically the same thing.
Yes. And then I'm going to replace anything that's in there with the object I just copied. And I'm going to click create. So now what I did is I'm going to, in a sense, I'm tricking Lambda into thinking I'm the Alexa skills kit and I'm passing it an object. You wouldn't be able to do this from outside. I can do it because I'm still inside like the DMZ if you want. So now I'm going to click here.
And if you're if you're working with AWS Lambda for anything, it's a good idea to use to configure test events to help you with your development cycle.
Yeah, and you can see the console log right here and do all these different things.
So one thing about this is that you've built this locally and it's tied to your account.
Yeah.
And so it's not out in the world.
We haven't
published it. But however, for those devices that you actually have registered, it'll work on those.
Oh yeah, so this is going to work on any device that's registered with the same developer account that I'm using on developer.amazon.com.
Very cool.
So I'm not doing anything special on that device. As soon as I make changes in my code, I can trigger it and I can hear it.
Right.
I'm just being a little bit lazy because I want to see it console logs and everything a little bit before I do that. But
Lazy devs are the best devs.
Every-
'cause they only do
Cautious
it
devs.
once.
Cautious devs.
every device that's associated to that'll work. It could be my phone, it could be that Echo Dot, it could be a Sonos speaker at home.
right.
It doesn't really matter. And you don't have to do anything to enable it. It just kind of works for free. So here we're going to click launch request, which is the one I just created. That's going to pass the object in when I click test.
And we can see the results right here.
We can see the results right here, right? So it says, this is the Twitch raffle extension. Please say blah, blah, blah. Pick a winner, end raffle. And we also see the reprompt here, which I just created. What would you like to do? And some additional information. Now, like you mentioned, we already had one in there for start raffle. So I'm going to try that one out now and click test on that. And that's, you might even see that it's a little tad slower because it's making that HTTPS request. And what it says here is, oh good. There was an error.
We can do some live debugging.
Please try a different command. So that was my error handler inside my own.
Get through some real deal stuff.
So rem prompt. We have a typo.
I have a typo. So, like I said, I'm known for
that one was right. There was another one that said rem prompt.
Oh, this one? Reprompt.
Yeah, that one's good. And then I think there was another one that said rem prompt.
Where could I have done that? Rem.
There we go.
Oh, look at that.
Pair programming for the win. Get rid of the M there. There we go.
Reading and writing is hard. So now I'm going to hit save, and I'm going to hit test again.
Yeah.
I'm not changing the event. I just want to use that same event to test. And now I get a response. Now, one of the reasons I didn't want to do it from the device is because it would take forever to read this out.
The UUID from our raffle.
Because it's a bunch of numbers.
Right.
So it says the response was blah, 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 because I'm not doing any parsing in here.
And because we're treating the invocation from Alexa the same as a interaction from the GUI, from the extension front end.
Right.
So what we could do,
We could change our backend to output something that was easy, so he doesn't have to change this code for the Lambda for Alexa, or we could do the reverse.
So what we can do right here is, right now what we're saying is, the response was, and then we're stringifying just the whole response, which is a little lazy. We could wrap this, we could wrap a variable in an if, and if there's a response in there, just say the raffle was created successfully.
We could, in this case, because we don't care about the response, we could look at the HTTP status code, and if it was 200, we knew that we were successful.
Yeah, so we could do that in a second. I want to build the other handlers first, and then we can start playing around with this.
Yeah.
So the next one that we're going to build, all I'm going to do is really cheat, which is grab this whole start raffle intent handler,
And we'll make another one.
and I'm going to make another one that's exactly the same. And I'm
Pick a winner.
Yeah, and this one's going to be, instead of start raffle, it's showing me an error because I'm basically naming two constants the same. So I'm going to call this pick winner intent handler.
Yep.
And the first thing I'm going to change is this flag here, so it returns true for the other intent.
Which we called pick winner intent.
Yeah.
But it's good to copy paste in case we
I
forgot.
have the worst memory. Gabe can attest to this.
Slightly better than a goldfish most of the time.
Yes. So
Fish, huh?
I'm going to put it here.
There we go.
And then now it's only going to return true when we get that intent. And this is pretty much going to stay the same helper function, except instead of being prod raffles create, the path we're going to hit, it's...
Well, here, let me look. I'm pretty sure it's prod raffles and then a winner. I think it's just instead of create, it's winner. I'll check for you on my code while you're making that.
And this is all related to Gabe's actual API gateway. These are the verbs for his API, right?
Yes. So it wants a ID in there too. So raffles / and in this case, you can put anything, because something that we haven't explicitly called out yet is, I wrote this thinking at some point that we would want to handle multiple simultaneous raffles for different channels. But at this point, the code is actually ignoring whatever raffle ID is coming in. But in order to make the URLs parse correctly, you're still going to need to pass something in there. So you could just pass in 100 or anything, just so it matches the routing.
So I'm just passing a number right now that's going to be hard-coded. But we're kind of leaving ourselves some room to make it multi-tenant in the future.
That's right.
We didn't want to go through one-way doors, to be very Amazonian speak about it. So now that we know what we're going to call, we also want to customize what the response is. So now what we're going to say is, I'm going to leave the response here because I want to look at it, because I might be, Gabe's usually based in Singapore, so I might be doing some hacking while he's sleeping.
That's
so
right.
I want to see his responses and not have to bug him to modify your API. In the real world, you might be hitting an API from someone that doesn't want to talk to you at all, or charges a lot of money to talk to you.
Right.
So you want to be able to look at this and just self-serve in a sense, right? So I'm going to leave everything else as is right now. And I'm going to make a decision right now, and I'm going to get rid of this reprompt when the user says pick a winner. It's just going to pick the winner and end the session. It's not going to wait for you to say anything else.
That makes sense.
So I'm going to hit save. And
now again, The backend isn't yet optimized to emit something useful for it to say, but we can go ahead and make that change if we wanted to.
So I think that's the next thing we'll do. We'll just build this
Yeah.
this handler, the next handler, and then we'll do that. So let's just go ahead and build the last handler.
Yep.
And that one's slightly different, but almost not at all.
This will be the stop handler.
The stop handler, yeah. So the slight difference here is that instead of being this random name, it's going to be Amazon, all caps, period, stop, intent. And if we want to double check or copy paste, we can see it here, right?
Yep.
It's this guy that we're going to use, but we're also matching just against the name. And this error here, session expired, is what I was saying. Saving
Save
in
often.
this portal is a good practice. So do it early and often. So now we have.
We lost the A.
We lost the A. Amazon stop intent.
Cool.
And I also want to change the name
Yep.
for this, which is stop
Intent handler.
intent handler.
Yep.
Now we created two new intents, but these are just variables in JavaScript.
Yep.
We need to register these.
Yeah.
So we need to register the stop intent handler.
Down there at the bottom where you're adding all the handlers.
The order that you register these in matters because
Right.
it's cascading through it. So if I move this unhandled intent to the top that just returns true, every response would just be that one.
That's right.
So I want to have the least permissive or the most specific at the top and the most broad at the bottom.
In this case, all of our handlers are specific only for certain intents, and
Yep.
so it actually doesn't matter for the rest of them what order they're in, as long as unhandled is at the bottom.
Correct.
But it's a good call out you make that it is going to cascade and flow through to the first one where the can handle returns true.
Yeah, and for people that have built skills before and they haven't seen the new SDK, this is different for them because
Yeah.
before it was a hard, like the only thing you could key off was the intent name. Now you could put your own variables there, and the can handle is
It can be
super
context aware.
Yeah, super flexible.
Yeah.
So that's a really awesome new addition to the new SDK, and the new SDK is available for Java and JavaScript, and there's more languages to come shortly.
Awesome. So we got stop intent and we need pick winner intent. Perfect.
And now we've got that. I'm just going to hit save, and I'm going to create one object for each of these in the configure test events just to test them.
Before you go on, can we go back to the stop intent handler?
We
need
didn't
to-
fix the
We have to change the
HTTPS
URL that
request.
it's posting to.
So
Yep. So that should just be a delete verb to the same pattern with a raffle ID,
And
no
then delete.
slash winner. No, it's just the ID. Get rid of the slash there. Yep. And then the method instead of post, it's delete.
oh, cool. So now we fixed the HTTPS. Thanks for checking that out. The beauty of pair programming right here on stream. So we got that all built out. I'm going to show you a little bit of the JSON object. I'm going to actually edit that JSON object instead of going to the simulator and creating it. So I'm going to click Configure Test Events. I'm going to hit Create New Test Event, and I'm going to flip this to Start. Here we go. Start Raffle. And
We'll call it something different though.
Yeah.
For the name.
Yeah. Oh, for the new one, we're going to call it Stop Raffle. And then here, we're going to change the intent name. So inside this little object, the type is intent request. It even has a locale, which is the language that this is being spoken in. And then finally, what the name is. And we know this one is Amazon.stop.
Yeah, and the nice thing about this is, that little bit of code that he just changed, that piece of data is the only thing that is really causing our different functions to dispatch in different
Yeah, for
ways
what we're
in our-
doing.
For what we're doing. So
Yes.
that's why we can do this so easily. We
Yeah.
don't care about any of the other stuff in that payload.
Yeah, exactly. For the time being, we're not looking
Yeah.
at anything else. If we had it multi-language, multi-tenant, we'd be looking at a lot more things.
Yeah.
But let's just create that stop one,
Yep.
and then I'm going to click on that one, and then I'm going to click test, and let's make sure that doesn't. So what it said is
Status
the
deleted.
response was status deleted.
Yep.
So we know we're still hitting his API. It's all working pretty okay. So finally, we want to test the pick winner.
Pick winner.
Where are you? Oh, here we go. So I'm copying the intent name because that has to match verbatim
And we'll
in
make
our
one
event.
more.
And we're going to make a last event. We're going to create a new test event. We're going to base it off a raffle, pick winner, and finally,
We'll just change that
we'll
intent
just
name.
change it here.
Great.
So now we have an event in our test rig for everything that we can do, right?
Yeah.
It's not the most advanced, it's not the most complex, but it gets the job done.
And it's faster for testing this way and doing interactive, test edit cycles than talking to Alexa or going back to the other tab.
Yeah, and the only caveat there is that you can, since you're just sending arbitrary objects in there, you can get to states that are impossible to get to with your voice.
Right.
So now at this point, we've got those put together. Are we able to actually hit his back end?
The deployed version of it, yep.
So now can we pull up the rig and actually show these hitting?
Sort of.
If you have that, I think if you have that login set up, are you able to show those?
We can. I'm gonna change one thing. So on my computer, and I'm happy to, if we want to show this live, just put full screen on the primary. What I'm going to do is I'm going to configure my front end to talk to the deployed version of this rather than my local version.
Good.
And then even if I just load this into the developer rig, it's going to go ahead and load the version that was hosted.
Okay.
Let's see. I just want to think through this and make sure this will still work. He's going to talk to my extension. This is going to be showing that version. What I really care about is that the pub sub message comes through. That's only going to work if we look at the live extension, I think.
And so,
the rig channel you have is a fake channel.
So what we haven't talked about yet, and this is actually a good segue before we go on and actually test the true live connection, is we've been running this extension locally and testing it locally on my computer. But as we talked about before, in the Twitch extension development process, once you get it working locally, the next thing you need to do is package up those assets and give them to Twitch to host. And then you convert your extension from a locally tested method or mode to one that's hosted by Twitch.
Yeah.
I'm going to go ahead and tell my Twitch extension to serve the version of these assets that I've already uploaded.
Cool. While you're doing that,
Yep.
Let's go over on the couch and talk to these guys from Twitch about actually publishing and what you need to do and the pieces from that are involved with this. So, I've built this awesome Twitch extension, and it's amazing. It's going to solve everything we ever want. How do I get it out to the world? What's the deal?
Yeah, so I think the first thing to kind of understand is extensions have a specific life cycle, and then extensions have different states. So when you create your extension on the developer portal, it's going to start in local tested mode, and you can use the developer rig. You can run your front end and your back end locally. At a certain point, you want to go ahead and publish that and run it in a hosted manner. So you can graduate that to a hosted test where you upload your static assets, your HTML, your JavaScript. That's served out of the Twitch CDN. And you can actually, if it's a panel extension, you can go straight to your channel. You can install that extension and you can actually experience it live. You'd also have to upload, like you use the SAM deploy command line, you deploy that to a hosted version of your backend. So once those are both hosted, you can basically test it live on the site without releasing your extension.
So one thing you brought up though is that you put your stuff up to the Twitch CDN. So what's the CDN? What's that get me?
Yeah, it's the content delivery network. So anytime you have static assets pushed, from the edge, it's going to come from a local point of presence. So it's basically those assets can be served much quicker since they're already connected to the Twitch CDN to get assets for the Twitch site.
So the idea is,
Here's all my stuff, Twitch. Now you hold on to that, so I don't have to reach out and grab it every time.
So the idea here is that if I push it up and it's on the Twitch network, that no matter what for scaling, there are hundreds of servers around the world that are basically serving a copy of this content. And when I request it, it's going to find the closest one to me and actually serve it from there, so I can handle the scale no matter where the pressure of traffic is coming from.
You don't have to host those assets themselves.
Right.
Most of the time when we talk about scalability of an extension, we're almost talking exclusively about the backend's capability.
Yep, excellent. So now we've talked about parts of when you're publishing it and you've got it on the network. Does that make it live, or what do you have to do to get it to where it's like live to the world, like anybody and everybody can see it?
Yeah. So at a certain point when you're ready to actually release your extension, you would actually submit it for approval. There's a extensions moderation process. We have a team that actually looks at your extension and makes sure before you submit it, take a look at the policy guidelines and the documentation. Make sure that there's no CSP errors in the console. CSP, you're so jumpy on the acronyms, all right?
You know me, I'm just all about that. Yeah.
Content security policy.
Got it.
So this is basically, we have CSPs enabled on within the sandbox iframe that your extension loads in, just to make sure that you're not remotely calling or trying to do something that you shouldn't be able to do. And so if there's no CSP violations, anytime there is one, you'll see it in the console of the web inspector.
So you'll know it ahead of time. You got to put. In other words,
Yeah.
it's not like, oh, I'm going to push it up, and then they go, no, you can't have it because of this. You already knew it was there. You could see it.
Well, it's just kind of a checklist thing. Make sure you debug and look through the console to make sure it's there. Another thing I want to mention is that before you submit it to be reviewed, you have the capability of having the testing whitelist, so other channels can have your extension installed while you're testing it. And that's actually a great way. You can have some broadcasters, you can have your community try it out so that they can see it, but if everybody that's on that whitelist can also be a viewer of the extension as well.
Nice. Very nice. So then when you actually have that done, then it can go out to the world. I mean, how long would somebody expect it to take?
I think it's a week or two.
I think it's shorter than that. I think we have a published SLA of 48 hours, something like that.
There you go, even better.
So
But,
the best place to go is
yeah.
to go on Twitch's site and look that
You can see
exactly
the
up.
SLA.
I think there's an answer somewhere. Yeah.
Yep.
Yeah.
Yeah.
Okay. So yeah, we're not committing on camera here. We're
Yes.
saying that it is in writing. You can see it. It's on the site.
Yeah,
You should be able to
totally.
find it for where it is. But at that point, they're up, they're live, and it's going. What if when they want to update it? You know, I want to add some new features, right? So what do I got to get through?
The cool thing about extensions is there's a versioning model built into it. So you release an extension for the first time, you put out that first version. You can then create a new version of the extension that you're testing while the previous version is in released mode. So then when you're ready to push a new version, you would also submit that for review. And then once that is approved, you have the capability of marking that as released. So you choose when it comes out.
So you can push up a bunch of versions that are kind of waiting, and then you can say, this is the one I'm going to use. So and if you had an idea where you had different parts and features that you wanted to kind of put in your extension, you could do, okay, this week I'm going to use this one, even though you may have pushed them up a month ahead of time, and you could turn them on at will.
Yeah.
Does that sound about right?
Yeah, one thing to keep in mind is make sure your backend is backwards compatible, between different versions. So when you actually launch a new version of the extension, we will automatically be transitioning over. Broadcasters that have your extension installed will automatically get the newest version. But there's a time period where your backend will probably be servicing requests from both the old and the new version.
Any gotchas? Things that you've seen that kind of trip a few people up or that have caused
I think
headaches?
another thing to mention is there's a broadcaster whitelist. So when you create an extension, you can create it either for any broadcaster to install, or you can specify a specific set of broadcasters that have access to it. So this is really useful for if you have a owned and operated channel that you want an extension just for that one channel. You can make bespoken custom experiences. So a lot of broadcasters are big enough so that they'll have contracted out developers to make extensions just for them.
Interesting.
And so there's a lot of capability there as well.
Is that kind of tied to your account? Like, let's say I wanted to have a third party working on one for me. Like, do I have to? I just basically let them create it, and it gets approved under there, or?
Yeah, so they would create it in their account and then have that broadcaster ID in the broadcaster whitelist. Once it's released, the broadcaster would go to the extensions storefront basically to pick that out and install it.
Oh, I see. Okay, and then that's how they could use that. That would allow somebody like a third party, to be able to do your extension work for you.
Yeah.
Whereas you focus on. I mean, there's a lot of when you're working with Twitch. I mean, if you're a fantastic personality and you're really able to build up a large community, you may not be the coder of the year. So you'll have a third party do it, and so that you can focus on what you do best, and they focus on that. So that really kind of makes it a lot easier for them to work through that kind of workflow.
Yeah,
You seen
you said that from a streamer's perspective, but that's really true for game companies as well. I mean, a really specific or a really common use case I've seen is a lot of game developers are working in like C++ type of languages. Their web or front end skills might not be quite as experienced because they're just different techs. So you see them hiring out third parties to do this kind of work. That's super common. So
So a question from Not So Tin Man, which is, can extensions be private?
Yeah, so in that case, by private, I would have to follow up exactly what they mean. You mean the ability so that only certain broadcasters can install those extensions?
I think that's that's what I would have.
That would be that
gone with it.
broadcaster whitelist.
whitelisting.
Oh, just the whitelist. But I mean, once it's out in the public, I guess you can't like make it private so only certain people can get it. or certain publisher or certain
So
broadcasters
do you mean
could
from
get
a
it?
viewer perspective or a broadcaster
I
perspective?
think broadcaster perspective. If you put it out in the public, I mean, is there a way that you could only like, say I had 10 guys that I really like that are my broadcasters, and I want them to have this feature, but I don't want everybody on Twitch to have this feature. How could I make it private so only they could get to it? Is that
Just
something?
whitelist your
Yeah,
channels
use the
you want,
whitelist
right?
for the
'Cause
broadcast.
So you
would never really
whitelist
put
even.
it public because you want it private. It sounds like.
Yeah, well, I mean, it seems like a valid thing somebody might want to do.
Mm-hmm.
You know, if I have, let's just say I've got 3 partner channels, right,
Mm-hmm.
and that those are realistically they're outside people, but I don't want to publish it everywhere. I want it to stay private. So even though I'm still releasing it to the
Yeah.
world, do I kind of like blacklist the world and whitelist the 3 that I want?
Well, you're releasing it with a broadcaster whitelist.
Got it. Okay,
Yeah,
so
that's the answer
To
we're
make
looking
it
for, the
private,
vernacular of
you release
launching.
it with a broadcaster whitelist. That
Yeah.
basically makes it private. And then if you wanted to be able to add more people to it, you would add them to the whitelist, and you'd, I guess, is that like a republishing again?
Yeah, you'd push a new version to update the whitelist.
Okay. And if you didn't make it, I'm being silly here, but if you didn't make any changes, and the only thing you did was add a couple people to it, does that still have the same time period?
I mean, that should be pretty quick. I mean, it's the first review that's takes a little longer.
Okay.
Successive reviews, it can be a lot shorter.
Oh, that makes sense. Okay. So really, it's a lot of how somebody wants to be able to do this, and how they want it to work within the environment, and who they want to have it, and who they don't, and how that comes into play. Very cool.
Absolutely.
Very cool. So I think what we'll go do next is I want to talk about how we actually do some of the publishing on Alexa of these pieces. So we're going to jump back over to the dev desk, and we're going to chat for a minute and see what's the deal. I mean, hey, how do we broadcast this over on Alexa? What are the pieces we're dealing with here?
Yeah, so
If we wanted to publish the skill as a
Yeah,
finished
I mean,
product.
because like I know how to do it now on Twitch, but
Right.
but I want the world to, I want them to actually be able to use it.
Yeah, so that's some of that shared Amazon DNA. It's going to look a lot like what was described for Twitch.
Yeah.
So what you do is, let's say I'm going to go back to the developer portal. So if you can throw my laptop on there, it'd be great. Once you're done building your skill, there's that. Of course, I'm signed out. Give me 1 second.
Nobody speak while he types his password.
Look at me intently.
Yeah.
All right.
Intently.
Yeah.
Hey.
Nice.
Good
No
one.
pun there. Whee.
So you got this build tab, right? Where we were adding your intent requests, you're doing all this. You also have your test. So in build, you have these 4 green check marks that you're looking for. That means you're done building to a certain point. And then you can say, okay, what about distribution? And you click on distribution, it's going to ask you what the public name for your skill is, what gets published. Like if you go to amazon.com/skills, you can see all the skills that are available to you.
Right.
This is the name that appear on that website.
Okay,
And description and an icon and metadata. You give it some example phrases to let people know how they can use it, all of that. And once you fill all this metadata, you're also going to have a certification tab at the top. And in that certification tab, it'll show you if you're missing anything. In my case, I'm missing many things. But once you are done with that, you can click the submit for certification button, and we have a published SLA of 5 days. And what people will do is they'll actually run functional tests, and it's actual human beings that work testing skills constantly. And they'll give you feedback regardless of if the skill is published or not. So if it's published, they'll say, okay, it's live, people can use it now, but these are some things you could improve on. Or if it's not, they're like, this is a breaking thing. You say that you can do this thing, which is pick winners, but it never works. It just throws an error.
What's kind of the timeline between I put it out and I've got this thing coming up? How long does it take for me from when I publish it to when it's actually accepted and made public? And even if these suggestions are given back to me, do I have to fulfill these as an obligation before it can be approved forward? Or can I say, no, guys, I really wanted to do that?
No, so if they find something that they deem is going to break the customer experience,
Right.
they won't publish it.
Okay.
And they'll make you implement fixes for that. If it's something that's more of a cosmetic or like nice to have,
Yeah.
they'll publish it and give you the suggestion like, oh, why don't you do this?
I love the idea of audible cosmetics, by the way. That's just, every time I think of this, it's like, you can't think of the same thing. It's not like that.
Yeah, exactly. So let's say it just says something weird. Everything works, but you have a typo in there and it says "what" instead of "what."
Right.
They might let that slide. But if it's throwing a 500 error or just going boom boom, or
Right,
saying like
right.
there was an error,
Right.
that's not a
they're
good
gonna throw-
experience.
they're gonna
why,
throw it there.
why would we publish that?
So let's say I'm clean, I'm good, it's great, it's awesome, it's doing everything, customer experience is awesome.
It
What
should take
happens
about
next?
2 business days.
Okay.
The SLA is a little bit longer because over the weekend we don't have a 24/7 coverage. And once they approve it, it's immediately live. It's available for everybody in the locales you choose. So as part of the certification flow, one of the things that you're going to choose is what countries you want to make that available.
Right.
And you can go granular and say like these countries specifically, or anywhere where Amazon is available. And we will do certain things if it's an English model, for example.
Yeah.
And we find that it will work well enough in other locales, we will help you publish that really easily
got
to
it.
the UK or to Canada.
Right.
Sometimes it just doesn't work, right? Like if you had a skill that was about your pants, in the US it's going to make a lot of sense, but in the UK it's going to
means
be
something
your
very different.
underwear.
Yeah,
so-
it may be very, I could definitely see that. So,
call.
so at that point, we've got it, we built it, it's out, it's published, it's operating, we've got our Twitch extension, that piece is published.
That's all there is.
We're ready to rock and roll, right?
Yeah, at
So-
that point
so
you would have a whole product that you could start marketing or whatever. And like Travis was saying, you could publish that skill privately, with that extension privately. You could get your skill to a point where you know it's working.
Yeah.
And then the last step would be like, okay, make my skill public.
Right.
When you get that response back, you can start roll out your marketing, right?
So can we actually, I know you guys were playing with it earlier, can we get it?
Let's try it. We were
right.
testing it earlier, and we weren't seeing
moment
it
of
work.
truth.
Well, I think we're going to do some live debugging
Yeah.
on
So
the stream.
I
here.
think
All right.
I think we're gonna
Let's
actually
do this.
need some.
Yeah,
That's
it's part of the
right,
plan.
it is definitely part of the plan.
Let's start with showing Memo's screen, so the secondary laptop.
Should we turn it on?
Full screen. No, let's first just invoke it from
okay.
Lambda. We want to get that working before we introduce the Alexa
Okay.
to it, right? Yeah. And so let's watch Memo go ahead and trigger the start event, and we'll see what the response is from the server.
So I'm gonna just do start raffle, and then I'm gonna hit test.
And the fact that he got this response with an ID means that it actually went out to the API.
Yep.
The API didn't err out. As far as the API was concerned, it managed to put together a successful response and hand it back to him.
So let's see. Can you see it on the rig?
Well, so the question is, and this is where I think things are interesting and why we're going to need to do some live debugging.
Okay.
If you come back to my computer, the primary one, and first let's just look at the log from my server here. And I'll look at the most recent version here from the 38 minute. There we go. So this is the invocation that just happened. So this is me using the Lambda logs from CloudWatch. I can see that it's trying to broadcast out an event called Raffle Started with this information.
So
And go on.
Do you have that ID?
Yeah, I have the ID.
Let me open my CloudWatch logs.
Okay, it shouldn't matter, by the way, whatever the ID is. But you can look anyway just to see.
Let's see if it's the same one.
The interesting thing here is that my server also broadcasts out to the log. When it was successful trying to do the broadcast, it writes out what the HTTP status code was. So I get back a 204 when I try and do the broadcast from the server, which should be good, except the extension that I'm loading. So here I am on Alexa Twitch Devs, which is the account that this extension is authored under, and so I can see it here on my channel page. It doesn't seem to have gotten the event, because if it did, this UI would have changed. And so I don't know what that would be, except for
It's registering to listen to the broadcast topic.
It should be. And here's why I think I know that, and this is just me thinking out loud about how this UI works. All the UI changes that we see here are in response to the backend broadcasting an event to the channel. And so, for example, if I click Start Raffle here without using Alexa, then the state changed and said a raffle has started. If I click Join, and then I click Pick Winner, if I get back a user ID, that's my real user ID. So this is all working, and those events are, at least we know, successfully being broadcast from my EBS correctly to here. So I think the problem is not, can my EBS broadcast correctly? It seems to be, what could it be about the Alexa invocation of creating a raffle that's different, right? So just thinking out loud.
Let's pull up full screen on his, look at his CloudWatch logs and see what he has.
Well, we saw that
over
his
on his
request was
side.
successful.
So
Okay.
When you build that JWT for the broadcast, are there any fields in there that are taken as part of the request that comes in?
Let's check that. So,
And
Go
what
on, Emma.
I peeked on his CloudWatch, and I actually saw that the ID that he was seeing logged in his CloudWatch matched to the ID that I was getting as a response. So we know we're talking about the same thing. We're
Yeah.
seeing the same object. So it's really something.
So let's first go into something we haven't covered on the stream yet, which is my sneaky authentication way of saying, how am I authenticating Alexa queries? Because Alexa doesn't have a JWT, right? Alexa is hitting my HTTP endpoint the same way as the front end. The front end for the extension does pass a JWT, but Alexa doesn't, because Alexa doesn't have any context for Twitch. So the way we got this working was effectively with a shared secret in the form of a header that only Alexa knows to add, and which causes my extension to behave a little bit differently. So, go on, Mo.
It sounds janky, but it's basically a shared secret.
It's a shared secret. And we could make it a lot more secure, but we wanted to take a path of least resistance just to see that we could get this working first. So what I'm doing here is I'm saying, if I see a Twitch channel ID in the headers, I will remember that as the channel ID for effectively what the rest of my server is going to consider the content of a validated JWT. Similarly, I'm going to get the same thing for a user ID. If he passes skip auth as a header in, I'll set the user ID to whatever the contents of skip auth are. I don't think I need user ID for that request. I'm just trying to conform the two things that I do look at from a JWT later on in the code with what should be there for either case. So now that we've done those, then I've returned the authenticated credentials to the rest of HAPI. And then I can use that. So in our start raffle handler, for example, and I think then we'll go down and we'll look at broadcast. What's happening? We know start raffle handler is create raffle is finishing successfully because it is returning this, and Alexa was getting that. So it had no problem making the HTTP call, and everything seemed to work. And this broadcast seemed to work in the sense that we didn't get an airback from it. And the things that we should have used was which channel do we want to broadcast on, and that should have just come from the payload. Right? And we know that that was right because I looked at my log and it was saying it was broadcasting to Alexa Twitch devs, ALEXA,
But that channel ID is the numeric user ID.
Oh, it's not a string.
Yeah. So I
Also,
believe
let me
so.
Well,
see what
let's
the
do
logs
this.
do for the. No, this is a perfect way to do
No, I'm
this.
saying let's bring him up.
Yeah,
come on
come on
over
up.
here.
All right,
Come on over here.
This is-
I earned a
and
spot
let's
at
switch
the
around
desk.
since we're debugging.
Let's do this.
Some Travis
I can
magic.
see the same. We can see the successful broadcast happening here from interacting here, and then we can see what value we need to pass in there. Because, like you
Okay.
said, it's probably just that.
Yeah.
So we can verify that by first going to my logs for CloudWatch and making. I'll just collapse all these so we don't get a little bit lost, and I'll change this to say only show me the last 30 seconds of logs. We don't have anything here. Let's go ahead and let's invoke this here, and I'll click start.
And if you haven't played a lot with CloudWatch, it's a fantastic tool. Sometimes it feels like drinking out of a fire hose, but it's really, really good.
Okay, so what I log is broadcasting. It's not showing me the. Oh, there we go. There's just the logs weren't all the way in yet. There we go. So what's the channel? Perfect. See?
Yeah.
This is why we have the Twitch
Yeah.
experts here.
That's why we bring it up.
And so all we need to do to make this work is instead of having it be a friendly name, it's actually the user ID of the user when we say channel ID.
Our
So
secret.
that broadcast API endpoint
Yeah.
has the numeric user ID of the Twitch use. So there's a long history of using the username for the older API, but now we're going to, anytime an endpoint is represented, it's the numeric user ID.
Awesome. Let's just confirm this. 227114430.
Advanced technology.
227114430. Good.
So let's actually, so you've got that, you put that into the test,
So
right?
before he clicks send, let's just stay on my screen, and we'll go back, and I'll start with a fresh state. There's no raffle started here. And now he's going to trigger it from his test lambda.
Yep. And then the next test, we'll just do it from the device.
Okay. Let's see. And our
Hey,
UI
look at
updates.
that.
So we have debugged it. High
Yes.
fives all around. And
Thank you, Travis.
Yeah, no
Look at him.
problem.
He's like, I got it.
at this point, let me restart fresh by saying finish raffle here in the UI, and we'll start and see if we can get Braxton, do you want to unmute Alexa for us?
She's live.
All right. So, Alexa, open Twitch raffle.
This is the Twitch raffle extension. Please say, start raffle, pick a winner, or end raffle.
Start a raffle.
The response was, 3C8238920231 4298
Alexa, stop.
674B6F.
Stop.
Yeah. So
Thank you, Braxton.
Thank you.
Right.
that's why we didn't want to test it every time with
Yeah.
our voice, because it gets
Because we haven't yet written the part of code that would either have my server just return something, knowing that it was an Alexa request, it could return something real simple that Alexa could just say, or we change our Lambda handler that got called out to the API to parse the response in an intelligent fashion and figure out what to say.
Yeah.
So those were options. But the point is, it's glued together and it worked.
And we saw
Yeah.
this extension that is live, but not actually
Right.
available
Only
for anyone.
for certain whitelisted people.
For our whitelisted account, we saw it change the UI, right? And
Yep.
the code is completely separate. It's not running anything together. It's all rigged up the proper way with a API gateway and
And
all
to really note this is that even though you made the changes in the code here,
Yeah.
you didn't touch the device, you didn't do anything to the device, you didn't prep it, anything else. It's been sitting the whole time, and it was ready for it, as if you had loaded it in and got it ready to go.
Yeah, and
so that's really where the power of having, when you wake it up and you have the VoIP that goes in, and it actually hits the cloud computing side of it, that it picks up and it goes, oh yeah, I have this tied to this account, and it just works. So there's no staging involved. It just works.
That's right.
There's no compiling, there's no uploading
Right.
binaries, there's none of that. It's just like I make it. And that's why we picked Node.js, frankly, because we can just make those changes. If we're doing Java, we'd have to compile those and then upload those to Lambda, not necessarily to Alexa. And in this
Right.
case, I could just make editor changes in the editor live, and it changes immediately, right? So the next step, I guess, and I don't know how much time we have, and we do want to do Q&A. So
Yeah.
we're at the point, I think, where we can choose a few things.
Yeah.
Are we going to do Q&A? We can talk a little bit about what the roadmap for this could be, what the new features could be, or we could build out a little bit more.
Can we tell Alexa to pick a winner and end the raffle?
Sure. That's just, we're also going to interrupt her when she speaks the responses, but let's do it.
Yeah.
So let me join the raffle first. Hold on.
So when you told her to stop, that told her to exit that that
That's
skill?
but the raffle's still going.
Right.
Right, okay. So I mean,
So the broadcaster joined, just to make things simple here, right? Anybody can join, but we have the broadcaster also joined. So let's see if the broadcaster's user ID is going to get picked.
because I had this funny thing about if you're going to do a demo and show
Yeah.
them,
Yeah.
show the whole
Let's see
demo.
it. Let's see it.
Alexa, open Twitch raffle.
This is the Twitch raffle extension. Please say, start raffle, pick a winner, or end raffle.
Pick a winner.
The response was /I.D./.
Now we want to interrupt her.
3C823892.
Stop.
So interestingly there, it did pick a winner, but look at that, I got achievements here. But it didn't pick this ID, so I just want to see what this server responded with here. So if I refresh this again, I'll see only the invocations from just now.
And I'm going to make our responses a little less verbose while you do that.
There you go.
Look at that. So here's what happened. The channel that my extension broadcasts to, it needs to get that information from the context of the request, and we didn't update our intent handler for all the other intents to pass that correct header information in.
Oh.
We only did it for the start intent, or for the start raffle.
So we'll go,
And this is actually a great point to interject and say,
let's show a secondary machine, by the way, so people can see
Yeah,
we're
let's
making
go-
these changes
Thank
real
you.
quick.
a great point here is you start out, all developers do this, we copy and we paste and we change a little bit of things, but once you have some obvious duplication in your code, it's a good idea to go ahead and lift that out and refactor, and so you've only got that kind of important logic in one place. So one place we could refactor this code, we're not going to do it now, but we could make it so that all of the requests from Alexa are effectively signed in this different way in one helper function that all the different intents use in order to assemble the request.
I could just move all those headers down to my helper function that's already making the HTTPS request
Precisely.
and append them to the object there,
Yeah.
and then only what's changing in the object will
Yep.
get changed instead of copying and pasting it in 3 places.
Yeah, I think the best way to do it would actually just replicate the same JWT management. And since you have to sign your own to talk to the Twitch API, sign your own
Yeah.
to talk from Alexa to your email.
I agree completely.
And that would be a lot more secure to do it, right? So now I've added the header, which is
Yeah.
skip auth and Twitch channel
To both of ours?
to both
Perfect.
stop and pick winner.
Okay, so in this case, let me just let's restart. Let's do the whole flow again.
Okay.
And Braxton will have to interrupt
Did you
her
already
as she
punt
starts
the
talking.
verbose?
No, I'm going to do that.
He's gonna punt a little bit of the verbose so that we don't have to listen to
Oh, that's a good idea.
the sound of science. Excuse me.
Cool. This should have worked, is what we'll make her say.
Astra.
So which is that for?
that's
That's
what I
for
would've
winner. Do you want to do one for start also?
Yeah.
Yeah, good.
So cool. So at this point, now what we're doing is we're putting in the pieces here. We know we got to do a little bit of cleanup, but we're getting rid of some of the different debugging points, kind of making this run better.
Yep.
And now that you've actually saved it, it's up. It's ready. It can
Yep.
rock and roll. We don't have to really wait for anything.
Yep.
So let's boogie.
So, Braxton, can you do the honors? Alexa, open Twitch raffle.
This is the Twitch raffle extension. Please say, start raffle, pick a winner, or end raffle.
Start raffle.
The Amazon fallback intent has not been implemented.
So
What happens when you try to change too many things at once?
yeah. So that didn't so that was, it probably didn't hear me correctly, but we can, again, we're debugging. This
This is good.
So if you go to alexa.amazon.com as a user, you can see what Alexa has heard for you
For all of your,
for all your intents.
that's nice.
But this one actually mapped to my skill, and my skill didn't return anything, so it didn't get logged out. We're seeing here the joke that we used at the beginning when we were just testing the device. So that didn't do much for us right now.
So we just want to try it again?
Why don't we just try one more time first?
Yeah. Go
Yeah.
ahead. You want to undo it, Braxton? I'll yell at it. Alexa, start Twitch raffle.
This is the Twitch raffle extension. Please say, start raffle, pick a winner, or end raffle.
Start raffle.
This should have worked. Ask Gabe.
It did work, and if we go to the primary computer full screen for a second, you can see that our extension updated without me having to click start raffle. So that was good, and now I'm just going to join the raffle here as a participant, and now we can ask Alexa to pick a winner.
Okay, go ahead.
And you can do it in a single command. So
Yeah.
these are called one-shot invocations. So you can say, Alexa, ask Twitch raffle to pick a winner.
This should have worked. Ask Travis.
So if you were still watching, you saw that it did pick a winner. It happened to be my user ID. I saw a little bit of confetti on screen, so that was great. And
So
now
we can-
let's try
now
stopping
we
the
can
raffle
kill it.
too.
Alexa, stop raffle.
Oh no, well it doesn't know what skill
that's
we
right. I
want.
didn't tell what I want. You're right. Alexa, open Twitch raffle.
Oh, too slow.
Oh.
Alexa,
Tell Twitch raffle to stop the raffle.
This should have worked. Ask Gabe.
That didn't map to the right one. So Alexa, open Twitch raffle.
This is the Twitch raffle extension.
And then you
Please
say
say, start raffle, pick a winner, or end raffle.
End raffle.
This should have worked. Ask Gabe.
I don't know if end raffle is one of the utterances we gave.
That's my fault because my training data is not great. But you
Yeah,
can
we
say
said bail
abort.
out or
Oh,
abort. So here,
okay.
let's try this. Alexa, tell the Twitch raffle to abort.
The response was deleted.
Yep,
There we go.
that actually worked.
That's the
And
only
that's
one
it.
that I'm actually pulling out of the object
Right.
from, like I'm parsing the JSON that
Yeah.
I'm getting back from your endpoint, because the other one's just return an ID that doesn't mean anything.
right.
So-
That's why I changed it to ask Travis or
Speak
ask
the
me.
So if we switch over just to secondary machine, just for everybody who's actually watching this and understand why it didn't pick anything else up, that's because the only utterances he has to actually cause it to stop was bail out or abort.
Or whatever the built-in utterances from stop intent are.
And none of those built-in have the word raffle in them.
Exactly.
Right.
So we were saying stop raffle.
Right.
Right.
And it's the only one that has raffle is the start raffle.
Right.
Right.
So it's trying to restart the raffle, or it's doing like it doesn't really
Doesn't
understand
know what we're
it's
talking
doing,
about.
or it was hitting the fallback. It was like this is something I don't know how to handle.
Right.
Or pointing to the wrong place. So if we had one here that was stop the raffle and abort the raffle and stop raffle, that would fix the problem we were
Right.
having.
Okay.
The other one that we had was with start raffle. I'm misguiding my users because with the launch, like welcome, I'm saying say start raffle. None of these says start raffle.
Right,
They all
right.
are more verbose. So I'm going to add that one as well, just for like fixing, because this is going to get this piece is also going to get posted to GitHub.
Yeah.
That's right.
So
That's
I
right.
want it to be as good as it can be before we post it.
So the idea here is that, this is where you can take everything that you want to do and make it your own. I mean, this gives you all the starting fundamental building blocks for you to, if you've never built an extension or you've never actually built an Alexa skill, this gives you everything you need to actually build both and marry them up. And I know one of the questions that was asked was, has anybody actually built one of these before? Has there been an Alexa Twitch extension built before? So there's a question.
That's a great question.
I don't think so. I think this is an idea that we came up with. Like after reInvent, we started talking as like teams, multiple people. There's a bunch of great people behind the scenes here. Shout out to Gina specifically.
Yep.
She made this thing happen. It was a crazy idea that collaboratively, I don't even know who came up with. I know I've been involved for a long time, but I don't think this exists out there. So I was like, this is something cool that we should make happen. And I had to lean on a bunch of really smart people and get everyone involved. So we really appreciate that. So I don't think this exists out there as a product. We made a concept that someone can take and run with it. Like, actually tweet at me when you actually start making money with your first one, right?
So you know that point when you make something and you go, oh man, it's awesome. You live in that moment of euphoria.
Yeah,
welcome.
We're there.
But yeah, I mean, I think this acts as kind of just a concept of making any voice-enabled extension interaction. And so, some of on the chat were saying, raffles, moderators, are the ones who create raffles and everything. Why does a broadcaster need to talk to Alexa? It's really just as this serves as a piece of code that we are going to release where any voice action can trigger an extension action.
Yeah,
that's right.
And we just thought about what's a minimal scenario that the broadcaster might actually use, right?
Yeah.
It's not necessarily the be-all, end-all. We're not going to quit our jobs and go make a business making voice-enabled Twitch raffles.
Not yet.
Not yet.
Just hear me out.
Look at these.
But there's a ton of use cases. Like I love it's not through an extension, but the Destiny 2 Alexa skill lets you switch your loadouts on the fly by just yelling it out, right? And I always forget to change to my PvP loadout when I'm playing, and then I lose all my nightfalls. But like they're so quick that I don't have time to change. But I've actually yelled out like, "Oh, PvP loadout!" Boom, everything changes. Like it's magic. It's crazy. It's happening in game, right? So the sky's the limit for this. We just thought these are two really cool techs. There's a place where they dovetail. Let's show it off.
Or you could, there's probably an extension out there that does this, but you could have all of your viewers on the stream maybe vote for which loadout you should be using at any given time.
Yeah.
Yeah,
And I think that's the great thing about building developer platforms is we're not the people that make the coolest stuff.
Exactly.
Like you guys make the crazy stuff.
That's the best point. Like I like to tell developers that we're spending all our time building tools, building systems, making the ecosystem better. But the really innovative, the groundbreaking new businesses are going to come from them.
It comes from you.
Yes. And that's the whole point, is for us to basically put together all the building blocks and the pieces so that you can really innovate and do the super cool things. And that kind of brings me to the next point, is that some people are like, it's kind of cool, but like, what else can I get out of this? What's some of the incentives? So I guess on the Alexa side, what are some of the incentives that people can get by actually building skills?
Yeah, so the first kind of the floor of that is AWS credits. And I know Twitch does that as well. So if you build an Alexa skill and it's live, you can request AWS credits, and we give you $100 per month to just play around in AWS. And that goes pretty far. It doesn't sound like much, but it goes really far.
Before you go on to other incentives, it's a good time for me to mention that in addition to getting free credits for doing things like building Alexa skills or Twitch extensions, there's also a free usage tier on AWS. So if you've never used AWS before, there are a lot of services that you can get started with for free. Some you get a monthly allotment for, I think, for the duration of the account. Some it's for the first 12 months of the life of the account. And that's a great way to get started as well. So if you are doing things and you don't yet, you don't have a live extension published yet, or you can't get that credit, you can still probably start out for free. And so you can just go to, Amazon.com/AWS/free, I think.
Yeah, or
someone
activate.
can look it up in the chat.
Look it up in chat, and you can see how to get free usage tiering going as well.
And that's a great thing, because what we build today, I'm pretty sure is going to land on the free tier that's forever, because Lambda gives you 1 million invocations a month for free.
Yeah.
That's all our compute. We're using a little bit of Dynamo.
Oh, just barely any.
And that wouldn't hit any of the thresholds. So everything that we have here, you can deploy to your own account for free to just play around. Obviously, if you suddenly have 100,000 users a month, that's going to change quickly, but you should be making money by that point.
But you can get all the way up to the point of the day of release.
Oh, for sure.
And not have to spend
a single penny.
And that's exactly it. And part of it, understanding where some of these incentives come from, That's the other part about GameTech, and that if you go to aws.amazon.com/GameTech, you'll find a lot of these other resources that tie into each one of these areas, where you can find those credits, how you can get involved with those, and even through other different segues that we haven't talked about today. It's a great resource for you to start at, regardless of where you are in the ecosystem. If you are somebody who is a developer, somebody who's a studio head, somebody who's a streamer, somebody, just all the different areas, you can find everything at that central hub. Yeah. And that's what it's all about, because we know that there's a lot of pieces here at Amazon. You know, we've got some of the best spices in the world of everything you ever want to do. But being able to figure out what those pieces are and what are the best ways to do it, that's the point of a lot of things of what we're doing here. And that's what we want to make sure we do, coming up with more innovative and cool ideas like this that you can take and produce some of the most amazing stuff. So one of the things I want to do is I want to open up the Q&A and let everybody be able to start asking a bunch of questions while we talk about some of the things in the roadmap and continue forward. And I'm going to basically just interject, cut them off, and we're going to throw questions out there. So fire away.
One thing we kind of didn't mention on the Alexa side is the way you can make money with skills, right?
Yes.
And one is if you're building skills and they're really, really engaging, even though it's free for the user, Amazon will pay you out based on the most engaging skills. So I think that's a great way to do it. And then we just announced in-skill purchases. So you can buy entitlements, like physical, digital goods that you'll be assigned to your account, where it could be a subscription to a podcast or something like that. It could also be something completely digital, like all access to all the things in a game, all the levels, everything like that. We don't do digital currencies, but it could be, let's say you're building a whole game, voice game, it could be a new weapon for your orc or something along those lines that they're going to keep, that it's going to be attached to that account forever. And that all happens through Amazon Pay. So if you're also a Prime member, you get a discount on all of those purchases.
Oh, that's cool.
As a developer, you don't have to think of any of the complexity. You just say, this costs $3, and when the user that's an Amazon Prime member tries to buy it, they get a discount.
Nice.
And you don't do any, like, all the heavy lifting is happening on the API level. So that's really, really cool.
You know, thinking of this though, on the AWS side, if somebody had something that actually was for longer term, not just kind of a fire and forget, and they wanted to do it with an instance, they realistically could retrofit some of these pieces into the micro instance, which I believe is part of the free tier. So, you know, many people were going, well, there's a lot of Lambda love going on here. And there's good reasons for it, because it's
scalability,
really,
high availability.
Right, but if you really...
We all have serverless tattoos.
But if you're really that far down the road and you want to not do it with that kind of thing, you can spin up instances. You can spin up a copy of Linux or Windows and build these pieces to be in that environment and still be inside of the free environment. So you're not actually having to pay for it, just for what you're going to put together. So I don't think there's limitations that keep you from doing the things you want.
Or if the technology stack you're proficient with just doesn't meld with Lambda, you can do it this way, right? Like you know a different language, or you have this framework that just doesn't fit into that. Hey, knock yourself out. I see all the serverless memes there where it's like, oh, you do microservices, bro, and it's just a guy with a billion cables all plugging them together.
Ironically, when I built my first one of those, I did all mine in Python, actually. I wound up using Python and Lambda because for me it was easier. I could throw up a Python debugger, jump in there and step through all my stuff. And it just, for me, I liked it. It's not that I think Node.js was any lesser. It just, for me, I was real quick to jump in.
And I made the choice to do the back end for my extension in this stream with JavaScript also, because we were already using JS for the front end, and I thought, let's not put more languages into the mix if we don't have to.
Yeah, some people on stream, when I was kind of reading the chat, were saying like, oh, isn't React overkill for the extension? And if you just think of it like it's plastering something on the video, it might seem like that. But when you're doing verification and security and it's receiving things,
or just all the UI updates. I mean, to be honest, I started without React. I was just using the sample color cycle extension, and I took out the code I didn't care about, put in some new stuff. I was adding more jQuery event handlers, and I actually got to a point where I was just like, at this point, there's a lot of state rendering, UI rendering from state going on in a yucky or a way that felt not as clean as it could be to me based on my own comfort level and experiences. And that's when I just said, let me figure out how to get this working as a React app, because it'll make my development lifecycle faster, and also I think it'll give me cleaner code.
And being proficient with the tools that we're using today allows us to debug quickly, right?
Yeah.
If we had built something that we're not comfortable with, we'd be like, I don't know, man.
That's right.
Plus confetti.
Yeah, plus confetti. I don't know if you all noticed that, but when it broadcasts confetti out, I just found a React confetti component that you pass a property to, and whenever that property changes from false to true, it makes confetti appear.
I think chat was pumped about that.
Oh, good. So that was the easiest part of the extension.
Someone noticed it.
So we had a question
Where's the
that
confetti gun?
came up. This is actually for the Twitch side from, I think it's Not My Cult. And it said, are you allowed to write a script that automatically whitelists everyone watching your stream?
So the whitelist applies to the broadcaster that can install an extension. So when a broadcaster has a released extension installed, any viewer can see that extension.
But while it's effectively in a private, not fully released mode.
No, in a released mode.
Right. Okay.
Yeah. So the broadcaster whitelist is basically like these finite number of broadcasters can install.
Okay,
the
so it's not
released
really for the
extension.
It's not on a
for the
viewer
watchers.
basis.
Got it. It's
It's
on
just
the
on the
broadcaster
viewers.
basis.
It's
Yeah,
on the
exactly.
broadcasters. So another question that actually came up is that we were talking about third-party devs and things like that who could be building for others. Are there any channels where streamers are actually looking for people, or that you've seen in the community that developers can kind of find? Is there anything like that?
There's a page in the forums somewhere, or like on the dev site. Somebody can probably link it up. But
there's
I know
also
there's
the Twitch dev server, like the chat server. So we have a Twitch developer chat server room that you can go into at any time, and there's always a lot of devs in that. So that's where I would go to.
Okay.
Yeah, and I think it's also important to call out the fact that we have multiple Twitch channels where we're doing live coding like this constantly. We joined forces like Voltron to do this amazing thing. But I'm on stream on the Amazon Alexa channel 3 times a week, just building things on skills.
Twitch.tv/AWS. A little love for the AWS stream.
I need a switcher like that. Yeah. But if it's all black on black, I don't think I'll be able to read it.
That's right.
So another question was, what is Twitch's policy for the monetization of people using extensions EBS? Is it a premium service with extra features?
So the EBS is actually hosted by, that is the responsibility of the developer.
Right.
Yeah. So,
for now, anyway.
Yeah. And so we are working on coming up with new features to basically make configuration stores to kind of take away some of the easiest tasks to make that a provided kind of EBS type solution. Yeah. But right now the back end is up to the developer to choose and to deploy with whatever technology they see fit.
Yeah. Very cool. One other thing here was about live broadcaster user analytics. So you kind of recently released the Dev Analytics for games and extensions. They have analytics for the viewers on demand, but they'd love to have an API connection for live statistics for broadcasters and viewers.
So yeah, basically live statistics. That's great feedback. I can give that to the analytics team.
I've gotten that before as well. Yeah,
Not
available right now.
Can I plus one that?
Yeah. So we do have something similar to that, but it's right now we have a program called Drops, where game developers can get real-time viewer data based on who's watching for linked accounts. But again, that is limited right now to game developers that own the IP of a game. So if you're just a broadcaster, we don't have the concept of drops for a channel.
Okay.
But that's something we're looking at.
Cool. Because my marketing team would love that.
Absolutely.
So I guess we'll do kind of a couple things real quick and just roadmap. Tell us a little bit about kind of a couple minutes with the roadmap of what you see coming up.
For the extension we just built, or for Alexa in general?
For the always yeah, you're right. I know you can't talk about in general. I mean,
So this is
I'll give can.
It's
a question.
What I can tell you is, on the Alexa team, our goal is to be everywhere where Amazon is. So if we have a store, if we do Prime, if we have Prime Video there, we want Alexa to be there. And we've done incredible strides this year. It's just amazing the number of new locales that we've launched. Sometimes it's kind of funny to think that, EN US versus EN UK doesn't sound like a big deal, but it's really, really big for us. And something like ENIN, English for India, is so far removed from the same language model, it might as well be a different language, and it's amazing, and we're super happy to have customers there. We've got Spain, just announced maybe 4 days ago.
Cool.
Italy just announced, and France was announced a little bit earlier, and they're about to hit street date with devices and all that. So it's really, really exciting for that, and brand new languages, brand new models. Obviously, I have a special place in my heart for when Mexico is going to come out. So I'm waiting for the date.
You'll be there for that one.
Oh yeah, for sure.
On the AWS side,
Yeah.
I would say the best way to find out about what's coming up is to come to reInvent, which is our annual conference that we have in Las Vegas.
When's that?
It's in November.
November,
Okay,
the
cool.
week after Thanksgiving.
Yep. And so it's coming up. Registration is open. Take a look. If you've never been before, it's a very big conference. We had, wow, I don't remember the number. We had
It was massive.
over 40,000 people, I think,
Yeah, it was
last year.
It was crazy.
So, and if
So it'll probably be bigger this year, and
you're
it's the best place to learn about upcoming AWS announcements. That's where all the big announcements get made for each year.
And you can actually find the people and touch
Oh, yeah.
and touch them and be able to say, hey.
I'll be there. Viewers watching, I think, are you going to be there?
I'm going to be there.
Yeah, I'll be there.
Yeah.
We'll all be there.
Ask before you touch.
We'll all be there. Come and meet us in person,
Yeah,
too.
and I just this week I'm putting a plan together to do some streaming from reInvent. So you'll catch us on stream if you can't be
Sweet.
there in Vegas. And if
Same.
you're there, there's going to be a ton of Alexa content. Like I
Yep.
just saw our content slate that I have to edit, and it's terrifying. So it's going to be great.
I mean, if we're pimping events, I've got to talk about TwitchCon.
Yes, you do.
Yeah, TwitchCon's in October.
The question I have is, are we going to get invited to TwitchCon?
You guys are
Last year,
that's a
last year
great
I
question.
missed out.
Yeah, yes, absolutely. And so we have a dedicated developer day at the beginning of TwitchCon. So we'll have a day of content. We'll have some sessions where we talk about different topics. It's a great time for the developer community to just get together and ask me some of these questions in person as well. So I'm excited for
So I'll
it.
make a massive announcement. I'll be at TwitchCon too. Like,
I'm going to be there as
I
well.
haven't
So
asked my
yeah.
boss, but I'm sure he'll be cool
Yeah,
with
so
it.
that's October.
And keep your eyes peeled for Twitch Dev meetups as well. We just had the Euro Tour,
yeah,
which we
that's
didn't
right.
go to, but we had a couple of our colleagues there. I think Emily and Jamaica were in chat earlier, if they're still there. There's that, and I was just going to mention that we're constantly pushing the boundaries with extensions, trying new things like this. And I know something like just recently we did integration with PUBG for anybody that plays PUBG, where you can actually buy like Dr. Disrespect and Shroud skins for the game, but it's through an extension. So I mean,
Nice.
just cool things like that. Things are always changing. We're always looking for new ideas. So
Yeah.
Very
keep your
nice,
eyes
very
peeled.
nice. And then on the game tech side, a lot of what we're focusing on right now is taking all of these different pieces and examples of content and putting them into a centralized place where you can actually find them. Instead of you having to go to 10 or 15 places, we've got a couple things that we do, like a solutions builder there, and different places that you can ask or give certain things, like I am a developer. I'm looking to find things about Twitch, or I'm looking to find things on these technologies that I want to do certain things. And it will tell you all the pieces that you need to actually build them out, and it'll link you to the different solutions. And we're constantly updating this with content and things that you can do. And it's not just limited to one or two things. It's actually all the way across the board with all of the services, all of the different features. Because a lot of times when somebody says, hey, I want to build a leaderboard, there's more than just one piece. It's not like you get the leaderboard plugin and you drop it in. It doesn't quite work that way. And it depends on what you're looking for. If you're trying to find something that's fully managed, or you've got a bigger team that wants to build out pieces of it, it's a perfect resource for you to start at to understand all of the moving parts and be able to get the experts on each one of the teams to actually help you accomplish it and be successful. So I guess with that in mind, I think we're pretty good to go. I don't have really any other questions, and I think we're going to wrap up. So
Yeah, I
any
think-
last thoughts?
My last thought would be, if you enjoyed this and if you like what we built and you have ideas or you want to see other things, hit us up on social. And,
Yes, please.
Yes.
We're happy to collaborate and do more stuff that involves the three technologies, or maybe they don't want me anymore and they just want to see game stuff. That's also cool, but let us know what you want. We are all about hearing what you want, and we want to build what you want. And the more we hear from you, the better.
Absolutely.
Yeah, what he said.
Yeah, retweet.
Yeah.
Yeah,
We
yeah.
did it.
We're just gonna frame that one, box it, and just ship it everywhere. So, all right. Well, then, from everybody here, thank you very much. We really appreciate it, and see you later.
Thank you guys. It was
Thank
really
you.
fun.
Thank everybody.
Yeah.